This video is of the phishing module inside of the SOC Level 1 pathway of TryHackMe. And in this video, we're actually going to go through the phishing analysis fundamentals, phishing emails in action, phishing analysis tools, phishing prevention, and the Greenholt Phish practical exercise that basically takes us through some analysis of some phishing campaigns so that you can see how it's done in a real live environment. This video is sponsored by SurfShark, which is an all-in-one security solution that offers antivirus and VPN security of all of your devices, unlimited endpoints and unlimited devices for just 7 cents a day, which is $2.20 per month. So you can get access to that rate and that pricing through the link in the description below. And I encourage you to go ahead and secure all of your devices today. Now, without further ado, let's jump into the contents of the phishing module. Okay, hello and welcome back. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite system and network attacker. And we are re-recording the phishing analysis and fundamentals video today because yesterday or the other day when I was recording it, I was recording the wrong monitor. So the entire time as I was talking, it was not this screen. So that was, it was funny when I was going through the edit. I was like, I can't believe I did this. But anyways, so we are now here and we are going to do the phishing analysis and fundamentals video, which is a part of the phishing module for the SOC Level 1 pathway of TryHackMe. And as the name implies, it's the phishing analysis fundamentals. So we're looking at it from the perspective of a security analyst instead of the perspective of a hacker. I've done videos on phishing previously where we used hacking tools and a lot of other things to actually do phishing campaigns and do phishing attacks. But in this case, we're actually going to be looking at it from the perspective of the analyst, from the security analyst perspective. If you are currently studying for your security analyst certification or your Pen Test Plus or ethical hacker, any of those things, I recommend that you follow and subscribe and like this channel and turn on that notification bell so that you get notified the next time a video comes out. We only talk about cybersecurity and ethical hacking and all those things on this channel, and it actually will help you directly with your certification exams as well as your day-to-day stuff of being a pen tester or a security analyst, anything like that. So it's a really good resource. I do answer all of the questions that come in through the comment section, and if it's a long question, I will create a video to respond to it for you. So I'm doing the very best that I can to create a resource that not only you can use, but I literally started this channel because I also wanted a resource that I can just refer back to and find videos about certain things, and it helps me learn better when I have to teach it as well. So we'll be going down this journey together. We'll be becoming security analysts and ethical hackers together. So without further ado, let's jump into the introduction of the phishing analysis room. All right, as an intro, some cool things to know. There was somebody that created email, and we are going to do we get to see that here? I think it's in the next one. The email address is the one that we're going to talk about it. But in the introduction, we're going to talk about actual spam and the way that it started, when it started. So spam and phishing are engineering attacks. Spam is really just like, you should already know what spam is. I really shouldn't have to explain it to you. But it's basically just sending a bunch of emails to a bunch of different people without their authorization, and usually there's a lot of malicious stuff that's inside this spam email, like links that will either install malware on your computer or hook your device, and somebody can start watching your device and stuff like that. So spam usually gets filtered out, thankfully, because of all of the modern email clients that exist, and you really don't have to worry about spam. Rarely ever does spam email actually come through to your inbox because they're pretty good at filtering it. But phishing emails are a much more sophisticated version of a spam or like a malicious type of an email. And those things can get through your spam filters because they're not designed the same way that a spam email is. And they don't get sent out to a million different people that didn't authorize it. They get sent out to a handful of people. So it's a completely different type of attack and a different type of strategy for an attacker to try to get at us. It's a social engineering type of an attack. So the first spam email goes back to 1978, and the whole thing, I think, started in the 70s in general. And you know, you can, as an organization or as a security team, you can do all the recommended guidelines. You can do everything that you need to do to set up your defense strategy and have a really good defense system. But then all it takes is for the new hire that comes into the company who hasn't been trained or who isn't paying attention to just click on something inside their email, and the entire network is at risk. So it's one of those things that actually is really dangerous because it attacks the weakest chain link, the weakest link in the chain, which is the users. The human beings that are involved in the organization are the weakest links in the chain. Human error is the biggest reason for a lot of cybersecurity attacks because systems are pretty secure these days. So anyways, I'm not going to digress too much off of that. So there's a lot of stuff that help combat spam and phishing, but we need to just know what these things look like and how to prepare ourselves and train our people so that they know what's going on in that environment as well. We're going to have a machine that I've already deployed for this. It's the virtual machine that comes with this room. This is what you see on the right side of the screen right here. And we're going to be using the emails that are inside of this machine as use cases and as samples. These are the emails that they gave to us. And yeah, we're going to use those for some of the exercises that happen. So let's go into the email address, the history of the email address. All right, so I don't know if you've ever wondered this. I never thought about it until this room. The person who made the @ symbol famous is a guy named Ray Tomlinson. And he was a part of the team that was responsible for creating ARPANET back in the 70s. And I mean, I really never even thought about, I'm like, who made the @ symbol for the email address? Like, who came up with this, right? So the breakdown of an email address, if you don't already know, is that there's the username or the user mailbox, and then the @ symbol, and then the domain. So what it looks like is that, in this case, billy@johndoe.com. Billy is the username, the @ symbol is the @ symbol, and then johndoe.com is the domain. So Hank Hackerson at Gmail, or you know, any of those things. These are the standard domain username, email address syntax. And so you can, if you want to look at it in the context of your street address, you know, the street that you live on, the name of your street is your domain. And then there's your first name and your last name along with the house number that you're on. So the apartment number, the house number that you live in. And those represent your mailbox, which would be, for, in this case, Billy@Johndoe. Billy would be, you know, 1567 would be the Billy part of it, and then johndoe.com would be Santa Monica Boulevard, some shit like that. And so that's kind of how you can look at it if you want to analyze it or compare it against a physical address. So, you know, the postal worker knows where to deliver your email when they get your address. It's pretty simple. So the question for this one is, email dates back to what time frame? And that goes back to the 70s. It's right here where ARPANET came around. So that's where email started with. That's the time frame that it goes back to. So let's talk about email delivery. And it's going to get a little bit technical, but I think you can handle it. So let's talk about email delivery. Email delivery is done through 3 different protocols, okay? There's the SMTP, Simple Mail Transfer Protocol, and then there's the secure version of all of these things, because these are insecure protocols by themselves. There needs to be a secure version of these protocols. And then there's the insecure ports, which is the ports that are assigned to these things. And then there's the secure version of those ports. And we're going to talk about those in a little bit as well. But so SMTP is what sends the email. So we can call it the outbox. POP3, which is the post office protocol, is responsible for the transferring. So it's basically kind of like the cloud. When the email is in the cloud, it's in the POP3 protocol. And then IMAP, Internet Message Access Protocol, is responsible for the client and a mail server. So me using my email client Yahoo or Gmail to access the mail server to get my email, that's all done through IMAP, right? So it's three main protocols. POP3 and IMAP have the same definition, but they actually act differently. They have different purposes, right? So, for example, POP3, emails are downloaded and stored on a single device. IMAP, they're stored on a server and can be downloaded to multiple devices. POP3 sent messages are stored on a single device. The sent messages are stored on the actual server and can be accessed from multiple devices. On POP3, emails can only be accessed from the single device that they were downloaded to. On this one, they can be accessed from anywhere and they can be synced and accessed across multiple devices. And then on this one, if you want to, on POP3, if you want to keep messages on the server, you have to keep email on server enabled. Otherwise, when you read the message, it just deletes the message from POP3. IMAP, unless you manually delete it, it just saves everything and it keeps it for you. And you don't need to turn this thing on where it's like keep email on the server. You don't need to do that. It just stays there. This is what the visual of this whole thing looks like. So on the sender side, so Alexa at Jane Doe is the sender. And then notice that there's a SMTP server on this side and there's a POP3 IMAP server on this side. But what happens from Alexa is that it goes to the SMTP server and then it goes to the DNS server. So the SMTP sends the request to the DNS, DNS responds, and then that mail now goes through the firewall from her side. And then after it passes through the firewall, it goes into the cloud. And then from the cloud, it ends up on the firewall on the receiver side, the recipient side, and then it goes through the SMTP server. Then it goes through the POP3 IMAP server, and it stays over here in the IMAP server. And then Billy says, hey, you know what, I want to check my email. So he accesses the server, and then he sees that he has the email, and then he gets the email on his client, on his machine. And this is basically the process of an email being sent, right? And this is just a description of what I just said. So if you wanted to read this, you're more than welcome to pause the screen and read through that, but we just literally covered this. So we're going to move on here. Now, here's what's important about this. I mentioned earlier that there's a secure version of these ports and the port numbers are completely different, right? So SMTP's standard insecure port number is 25, but the SMTP secure port is 465. For POP3, the standard port is 110. The secure port for POP3 is 995. And then for IMAP, the secure port is 993. I don't know what the IMAP port number for insecure port number is. I have not memorized all the port numbers. I just know that I know POP3 because I've set up some email servers, so I kind of used it in a real world example, and I know SMTP because it's one of the first 25, so it's kind of easy to remember that one. But yeah, these are the secure port numbers, and so whenever you're doing anything, you need to understand that you need to be on these secure port numbers if you're setting it up for yourself. But then if you do a scan against somebody's network or their IP address or anything like that, and you see one of the insecure ports open without a secure port addressed as well, then you know that you can potentially capture their login credentials, watch their email, because everything's transferred through clear text. So there's a lot of stuff and there's an entire video of hacking insecure protocols, and it's one of the recent videos that's on the channel, so you can go check that out too. And we talk about a lot of the insecure protocols and how to get clear text usernames and password and all that stuff. So that was it for email delivery. So now let's talk about email headers a little bit. Okay, so email headers. Now we know that email goes from A to B and what's involved in that process. Now we need to understand the components of what an email actually is. So there's the email header, and then there's the body, right? So the header is the stuff that has the from address, the subject, the date, and then the to address. That's all in the header. And then the body is basically the email itself. So the syntax for email messages is known as the internet message format. And so this is what the header itself just looks like, and you should already understand what these things stand for, so we don't need to read that in detail. But this is just a visual format, right? This is if you wanted to see. So this is the from address, ADT Security Services. That's where it's coming from. The subject line is help protect your budget by protecting your home. The date that it was sent on is Monday, June 21st at 11:36 a.m. And then number 4 is where it's going to, right here, but it's been blocked out. So it's a Yahoo email address because this is probably an actual email address that's being used. So this is a snippet from an actual email. The email below is an image from a honeypot Yahoo email address. Don't engage, interact with the email addresses or IP addresses revealed in this room. And a honeypot, if you don't already know, is a trap that is set up for attackers so that they can try to get access to the honeypot, and then we reverse engineer their location and what they're doing and so on and so forth. So honeypot is actually, I love that as a strategy. It's a very, very cool strategy. And then there's something, I don't want to get too distracted, but there's like a human version of it as well, where they call them either a Romeo or a Juliet, that they act as like a human honeypot to attract, the hackers or the con artists, and then they reverse, and it's really cool. So the numbers in the above image correspond to the fields. Another method to obtain the same email header information is by doing the raw version of the email, which shows you the source code. So when you click on it, it goes from this clean version of everything into source code. And that is a little bit more intimidating to look at. And then in the knowledge base article from Media Temple, they go into the details of it. So if we went to the knowledge base article, this is what it would show us. And I think we even have to reference this article to answer a couple of the questions in here. Or maybe it was in the previous task that we had to reference to be able to get some of those answers. But anyways, that is also available for you. It's on Media Temple, and it's a knowledge base article for the raw full email headers inside various email clients. And so you essentially, on anything, you can click on the little triple dots or whatever that extra menu is, and then you look at the raw message, and then this is what the raw message looks like. So this is way different than what we saw at the top, right? So it still has the details that you're looking for. So it will still show you, for example, the email address of the recipient is still here, and there's the mail ISG code. I can't even begin to try to decipher this without using some kind of a tool. And then you have the subject line that's right here, and then the from that is coming from, and then the to, and then the date. And then you can see that, that this is like the source stuff. And the reason why this is important, you'll see in a little bit. So right here, we see from the above image, right? And then we can also review this by looking at email 1 EML, which is inside our attack box, our machine right here. So there is the originating IP. So this is the IP address of the email that was sent, and it's known as the X header. Then there's the SMTP mail from, or the header from, and this is the domain the email address was sent from. And then there's the reply to, which isn't always where it came from. So these two addresses could be completely different. So for example, in the email sample above, the sender is newsletters at anti whatever, and the recipient, if the recipient replies to this, the email is going to go to reply at anti. And so this is not, it's always not the same emails. Or let me rephrase that. The sender email and the reply to email aren't always the same email. So it's very important to understand this. And when you decipher, when you're trying to analyze emails on whether or not they're spam, what you see as the sender email, which in this case may be newsletters at so-and-so, that's what you end up seeing. That could be completely false. And you could actually be interacting with a completely different email address. So this is very important to understand. This is another source from Media Temple when we go into understanding an email header and what can actually be put inside of an email header. And I think we also referenced that. So it says what email header is the same as reply to. Yeah, and so we have to go over here, and this is where we would go to. We would go here, and I would search for reply to. Yep, there it is, reply to. And so it says the return path right here. The email address for a return email or for return mail, this is the same as the reply to address. It's the return path. And so that's our answer over here. And then once you find the email sender's IP address, where can you retrieve more information about the IP address? And in that case, it's going to be aaron.net. Can I zoom out? So once you find the email's IP address, where can you retrieve more information about the IP address? So we go and search here. Let's do more info, and then you have more info right here. And then if I go, okay, so let's see what else I could search for to find that. I'm trying to see what sender's IP address. So let's see IP address. So if we do IP add, there would be a few things. There we go. And so we search for IP address, and it says once the email sender's IP address is found, you can search for it as Aaron.net, so you can see whether or not it is a malicious IP address. So that was a good resource to have, and it's something that you should definitely keep track of as you go through these things, right? So let us now look at the email body. All right, the email body should be fairly simple. There's two different versions of it. There's the text-only version and there's the HTML version. So a text-only email looks just like this. It's just text, right? An HTML formatted version can have images in it. This one is broken or it's been blocked. The image itself probably was blocked by the email client. And then there's hyperlinks inside of it. And the hyperlinks or images that are clickable, there's a lot of different things that you can put inside an HTML email. Those things they could have completely different emails associated with them. There's a video that I did the same night that I recorded this, and that one is also going to be up either in the same day as this video or slightly before, slightly after, but either way, there's another video that we did that looks at actual emails that were used in phishing campaigns, actual phishing emails, and then we break down what was inside it that made it look or made it really successful as a phishing email, and how to discern, how to tell why that was a phishing email. And a lot of times it's the link here says tryhackme.com, right? So the text of the link says tryhackme.com, but then when you look at where it's pointing to, it's not tryhackme.com, and it's going someplace completely different, and they get you that way. So it's very important to understand this. If you notice something fishy, and no pun intended here, but if you notice something shady about an email address or an email that's coming, you need to be very, very careful on whether or not you click on it. Start looking at the source code of the email to see where those things are pointing to, so on and so forth. So the above email has an image that was blocked by the client. We can add a lot of things because of HTML, and then the screenshots in the example below are from Proton Mail, and this is the source code of the email itself. And so you have, start the main content here. There's the image class logo, which is from Imager, whatever. Then you have Hi Heaven Renzia, so on and so forth. And then you have a new write-up submission, blah, 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 right? So this is the email itself. Now over here, right here is the actual email. Hi Heaven Renzia, you have a new write-up submission. This is the image that was blocked at the top right here. And then it goes all the way to for support, reply to this email, so on and so forth. So if we looked at the rendered HTML, the phrasing of this is different. So sometimes you just click on HTML and it shows you the HTML version. Sometimes you click on source code or source and it'll show you the code version like this. So the phrasing could just be different. In this particular case, because they were using Proton Mail, it goes, if you wanted to go back to the HTML version, you just click on view rendered HTML. So what else can we look at over here? There's another one. We can view an email attachment from an email's HTML format by looking at the source code. So over here, this is an email that looks like it's coming from Netflix, right? The web client in this case is Yahoo, but this is a phishing email. I think we actually even talk about this in the analysis of the emails video, where we were looking at it and they are asking for you to update your payment, like your payment form in Netflix, and they give you a payment update PDF, which is ridiculous. Where it's like, where do you know that would send, unless you're dealing with like a vendor that you know and they don't have any web collection as far as payments are concerned or anything like that, and they collect payments and payment information through some kind of a form. But at what point have you ever heard that Netflix would collect payment information from somebody through a form, like an actual PDF document? That's ridiculous, right? But this is it. So, and then when you click on it, when you look at the source code, you'll see that the content type is an application PDF, payment update, and then the content disposition is an attachment, so on and so forth. And then the transfer encoding is a base 64 transfer encoding. The content ID and the attachment ID are these things. And then these are important to understand because you can, when you look at these things a little bit, you can see that maybe, you know, certain parts of these things have shown up in a virus total database or something. So these are, it's important to understand, especially base 64 encoded stuff. You can decode it either through CyberChef or through your terminal, and you can see what the actual base 64 encoding is trying to say or it's hiding from you, and then look at, you know, analyze it further, right? Cautionary steps forward, basically. So when interacting with attachments, please proceed with caution and make sure you don't double click an email's attachment by accident, because it'll actually run whatever is inside it and open it. And sometimes when they put code inside the macro of a PDF document, as long as you open it, you run that code. So you don't want to open it, right? That's very important. So you don't want to accidentally open something and then run the code that's hidden in the background, and now your computer is screwed. So, or maybe even worse, your network is screwed. So headers specific to content can be found in various locations within an email message source code. They're not associated with attachments only. For example, the content type can be text HTML, and content transfer encoding can be 8-bit instead of base 64, for example. So in the above screenshots, what is the URI of the blocked image? And we found it from the source code right here. So this was the URI, and this is not copy pastable, so you actually have to type this out, and it's, you know, HTTPS imager whatever. So that's the URI of the image. What is the name of the PDF attachment? It's payment update ID PDF, and we see that right here. And view the information in email to and reconstruct the PDF using the base 64 data. What is the text within the PDF? Now this was something that I was like stuck on for a while. But okay, so here's what we're going to do. We're going to open up email 2, and then we need to find the base 64, the encoding of this, right? And then from there, we're going to go to CyberChef, and we're going to decode it, and then get ourselves the PDF attachment of this. So first, I'm going to open up Internet Explorer on this machine, and they want us to use CyberChef, so it's literally going to load Internet Explorer with CyberChef, and then from there we're going to get the base 64 encoding of this thing, and then go ahead and have some fun. So, all right, so the base 64 encoding is this whole thing. So we take this entire thing. I went to the bottom of the email, come all the way to the top, and then we're going to take this entire thing right here, and we're going to copy this, and then go inside CyberChef. We're going to paste it, and then now you see both of these things, and then we're going to do from base 64, so it decodes it for me. And now you see that the content has changed, obviously, as soon as this turned on. So if I turn this off, you'll see again. So this is what it looks like. They're both exactly the same. And then we turn on that we want to change it from base 64 into something that's a little bit more legible. And now we have this, right? So this is the you know, decoded version of this. So what we're going to do to make this easily accessible for us is we're going to save it, and then we're going to save it as a PDF. So instead of a DAT, it's going to be changed to a PDF. And then there you go, you have your download, and now all I got to do is just open it, and it'll open inside my web browser, and right there is going to be the flag. This took me so long to do the first time that I did this. I lost my freaking mind. I was like, what am I doing wrong here? because I thought I was supposed to read, like I was supposed to try to find the flag inside of the output here, and I was like, yo, this doesn't make sense. I don't know what's going on. Like, I can't find anything in here. And anyways, but yeah, that's what you do. So you first, you paste it in the CyberChef, you put the from base64 filter on here. It'll give you something that's like this, and then you save it. And then when you save it as a PDF, not a DAT. So you just change that from DAT to PDF, and then you save it, and then you just open it up, and there is your flag, benign PDF attachment. That's what it is. So there we go. We got our answer for this. And now we can move on to the types of phishing emails. All right, we got a good number of phishing types here. The first one, I don't know if this is considered a phishing type, but spam, I guess technically, could be considered a phishing type. It's unsolicited junk emails sent out in bulk to a large number of people. And the more malicious variant of spam is also known as mal spam. And that involves things that if you click on it, your machine will get screwed, or something will happen with your data, something like that. So spam, I guess, can qualify as phishing. Then we have the first layer of phishing, which is email sent to targets. Usually it's like several targets, purporting to be from a, or pretending to be, purporting is like, I sound so fancy saying that, from a trusted entity to lure individuals into providing sensitive information. Then spear phishing goes a step further by targeting a specific group of individuals or organizations. And for example, it could be the management group or the IT department or something like this, but they go for a specific group instead of just blasting the entire company. And then you have whaling, which is very similar to spear phishing, but they target even a smaller group, for example, the C-level executives inside the company, the CEO, the CFO, the CIO, etc., to be able to, because if they get that person's information, they probably have access to the entire company, right? So this is one of those things that I would venture to say that sysadmins or domain admins are also whales when it comes down to the context of maintaining persistence or getting access to a network. If you get access to the username and password of a domain administrator, then you are in their entire system and you can get access to the CEO's information, you can get access to everybody's information. So whaling is another version of spear phishing. And then you have smishing, which is done on mobile devices, which is through text messages. And this is, I mean, I get this stuff all the time. People just pretend to be my friend. And I'll be like, hey, Anna, where are you? Or sometimes I'll just literally just get a text message that says, hey, so what are you doing tomorrow? Like, I've never talked to anybody, and I get literally, hey, what are you doing tomorrow? And I'm like, who is this? It's like, it's, it's whatever, Betty, don't you know him? I'm like, what are you talking about? And at first I used to be really upset, but now I'm trying to string them along because I want to see how far I can take them and eventually send them a link to click on so I can see who they are and when they're from. And that's still a work in progress. I think I'm too obvious and they know that I'm messing with them and then they just move on. They don't spend their time with me anymore. But smishing is through text messages and then vishing is through phone calls. And this one is actually very, very scary because there are softwares like 11 Labs voice emulator where you can feed several hours of data, basically several hours of voice samples into this AI, and then it'll duplicate that voice, and then you can feed it a script and then it'll say whatever you want it to say in that voice. So if you knew exactly who I was and who my family members were and how to access my family members' contact information, and you called somebody in my family and used my voice, because there's so much of my voice available on YouTube right now, you can use my voice, duplicate my voice, and then contact somebody in my family pretending to be me. You understand what I'm saying? And it gets really scary. There's a lot of stories that are out like this that people just have gotten conned so badly because they think that they're talking to a family member, and then they just divulge a bunch of information. And one of the ones recently that I heard was they recorded the voice of the girl's dad, and then they called her using the dad's voice, and it was like he was talking in a busy background. It sounded like he was in like a busy environment. And then he goes, "Hey, what's your social? I'm trying to add you to this life insurance policy." And then she goes, "What?" It's like, "What's your social security number? I'm trying to add you to a life insurance policy as my beneficiary." And so she just gave her social security number because she thought she was talking to her dad. And just like that, she got caught. So it's very, very, very scary, the stuff that's happening with AI. And then there's these visual emulators that can duplicate somebody's likeness, and it's very, very crazy what's going on. So phishing is going to become a big concern. Social engineering attacks are going to become a big concern, and it's something that you need to understand. It goes way beyond email at this point. So yeah, just keep your guards up, be aware, be paranoid. The paranoid survive out here. So when it comes to phishing, the modus operandi, the MO, is usually the same depending of the objective of the email. So they're just basically trying to get the same thing done. They want to either harvest credentials or gain access to a system, or get your personal information, and so on and so forth. Typical characteristics is that the sender email and address will be masquerade as a trusted entity, which is considered email spoofing. So they'll pretend to be coming from Google, or they'll pretend to be coming from Netflix, but it might be designed or misspelled or something like this. Might be trying to come from PayPal, for example. This is another one. And then when you look at it, it's from a completely different person. It says it's from Bill Gates at Microsoft. You know what I'm saying? The return path would say that it's from Bill Gates at Microsoft, but in actuality, it's probably not. You know what I mean? There's a lot of stuff that can be considered email spoofing. The subject line and body text is written with a sense of urgency. So, confirm your order, right? Invoice, suspended, staff pay structure, or staff pay stubs, something like this. Like something that will make you be like, what? And then you just want to click on it because it seems either urgent or very curious, and you're like, wow, damn, I want to see what's going on. So the email body, HTML, is designed to match a trusting entity such as Amazon. So they'll use Amazon logos, and the format of the Amazon emails is poorly formatted or written with a bunch of misspellings. That's like the complete opposite of this. So you look at that, and then you see, oh, well, this looks like directly from Amazon. And then you look at this, and you're like, dude, you have like 5 misspellings, pretending to be Amazon, and you can't spell, really? The email body uses generic content such as "Dear Sir" or "Madame." That's very, very fishy. I've also gotten "Hello, dear," and it's like, who the fuck talks like that? But so hyperlinks, oftentimes using URL shortening services to hide the true origin of the hyperlink, or sometimes it'll actually say www.tryhackme.com. That's the text, and then it's hyperlinked to look like this. So instead of saying email spoofing, it says www.tryhackme.com, but then when you look at the source code, it's actually not the thing. So if I do copy link address for this, for email spoofing, if I do copy link address, I open up a new tab and I paste the link address, we see that it doesn't say email spoofing, right? It says whatever this website is. So if you do that, and that's just a very basic version of trying to find out what the hyperlink behind something is. So you can do that and see what the hyperlink behind something is. And then there's the malicious attachment, which we kind of discussed earlier. And all of these things, we're going to actually look at examples when we go into the phishing email analysis, where we actually look at previous phishing emails that were successfully used, and there were parts of phishing campaigns that now they're caught, and now they're in the public domain and people know about them, but at one point they were super successful. We need to remind ourselves again that when you're looking with hyperlinks or attachments, you got to be careful not to actually click on it or open it, or do what I just did, where you right click on it, you copy the link to your highlights, or right click on it and copy the link address and then paste it inside the thing. Don't press enter, right? Just paste it to see what it is, or paste it inside some kind of a text editor just to see what it is. And then there's the important part of defanging a URL. So when you send it to your security team, or somebody on the SOC team, or somebody else, your management, to be able to analyze it, you need to defang the URL so that it's not clickable. And that's very, very important. So if this is the domain name, if you send it like this inside an email, somebody could click on it accidentally. Whereas if you do this, it's no longer clickable. It's called defanging, where you remove the T's from HTTP, you put brackets around all of the dots, and then you do the same thing for IP addresses. You put brackets around the dots that separate the numbers inside the IP addresses, and that becomes a defanged IP address. So we're going to analyze email 3, which is inside our virtual machine, and we're going to answer the questions here. So let's go and look at email 3 here. So here's the email, and this is what it is. And so it says, what trusted entity is this email masquerading as? So let's go and try to find that information. So the first part is to try to find the coming from, right? So where is it coming from? And then from there, we're gonna find I think it's like an encoded version of this, if I remember correctly. And then we're going to decode it. So right here, the subject is this part right here. So the subject is something that we need to decode. What we need to understand is the UTF equals, UTF-8 is universal something something. So this is like it's a time encoding right here. And then it's question mark B and then question mark. So, and a question mark is an appending strategy. So when you put a question mark inside a URL, it adds something else to it. So these things that have been separated by question marks are all different entities. So from the what is it, the third question mark on all the way to the end of this thing is the actual information. So we're going to take this and we're going to copy this, and then we're going to go to our CyberChef and we're going to paste it in here. And let's see what I can do here. Ooh, okay, so it was not actually the subject line. I think I'm supposed to look at the sender, obviously. That's probably better. So instead of subject, or you know what, I think I do need this too, because this is, yeah, it says what is the subject line. So that's actually the answer for the subject line. So this is it. And just to tell you what piece of it was again, so it was from the third question mark, and you go all the way. So UTF is the time, B is for the base encoding, and then we go all the way here, and then you go to the very, very end of this, and you go all the way to that last question mark, not including that last equal sign, because it starts with an equal sign at the beginning, right? So you just take everything here, not including that last equal sign, and that's going to be what you paste inside the decoder in CyberChef, and it gives you your order placed, blah, 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 blah. So to actually get the one where it's coming from, the sender's email address, so we got to go from the from address, and same thing, go from that base encoded portion, and then we're going to take it all the way over here before that equal sign, and then we're going to go and paste that here, and it says thank you Home Depot. So it's coming from Home Depot. Now what is their email address? So we need to find support at techbee.com. So right here, support at techbee.com. That's where it's coming from. What else? We need the last thing. So what is the URL link for the click here that is inside that email? Enter the defanged URL. So what we can do here to make this easy, we can search through the email for click here, and then we'll see that we actually find it. And so it's right here. So now I need to go and get that entire URL, and HTML code for making a URL starts with ahref. So if you can find that portion of it, and I just want to expand this a little bit to make it easier, but it's giving me a hard time here. So it starts with click here. So this is it, or the text itself is at the end of the hyperlink, and that's what we see here, is that this is the text itself and it's at the end of the hyperlink, and this A portion right here, that means this is literally the very end of the hyperlink. And then when you go inside of this little squiggly line, the greater than symbol, you see a quote, and then you see a bunch of formatting information. So style, 3D, yada, yada, yada. And none of this has anything to do with us. Then we go here, and then we see that this one, this is another set of quotes here, right? So it starts with another quote, and then everything inside of this quote is the link. And then you see how it starts with ahref. So this is the beginning of that hyperlink, and it goes all the way over here. This entire thing is that hyperlink that says click here, and then all you see is click here. But then the formatting is different, so on and so forth. And this is what we want specifically for our defanged URL. So we're going to copy this, and we're going to go into CyberChef, and we're going to paste it. And then we're going to turn that off, and then we're just going to say defang inside of our options here, and we're defanging URL. So you drop that in here, and the response down here is going to be the defanged URL for the whole thing. And you just take that, you copy that, and then you come here and you paste it, and that will be your defanged URL. And just like that, we have answered all of these questions. So types of phishing is now done. Phishing analysis fundamentals is now done. And the conclusion is, I mean, it's very basic. So it just tells us what we covered here. So not a big deal. There is a question at the very end that they ask, what is BEC? And at the very, very top right here, it says BEC is business email compromise. And it's when an adversary gains control of an internal employee's account and then uses the compromised email account to convince other internal employees to perform unauthorized or fraudulent transactions. So it's basically getting somebody's email address and then using that email address to pretend like you're that person. And a lot of people put their work email addresses in their social media profiles. So this is not hard to do. You can literally search for freaking, you can search through LinkedIn. If you know how to do Google hacking, you can search through Google and look on LinkedIn and try to find people's email addresses inside of their bios. And that is just insanity to me. But yeah, that's a very, very important note to keep in mind, that this is actually a thing, that people can find your email address and then pretend to be you, and then go out and hit up all your coworkers and try to find somebody who doesn't pay attention. And next thing you know, your organization is screwed. Anyways, that's it for the phishing analysis fundamentals video. If you learned anything from this video, or if you're studying for your security analyst or ethical hacker, SOC Level 1, pen tester, any of those things, then I welcome you and I encourage you to follow and subscribe and turn on the notification bell, like the video, drop a comment, all those things. It actually helps our channel with the Google, YouTube algorithm, but it's also very important for you, because if you're studying any of those things for your certification, or if you want to become any of those things in your career path, all of these things apply to you. Every video on this channel is directly designed for you so that you can go and become a better version of whatever it is that you're trying to do. So it would be useful to you, and then it would be awesome to have you as a part of our community. And we're growing a community. It's a beautiful community. I love everybody that's joining, and it's really, really fun to see the growth and see all the comments and people making smart ass comments. So it's fun to have this community. Hackers are funny people. They're fun people, and it would be awesome to have you as a part of our community. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker, or network and system protector in this case, because we're studying the SOC Level 1 pathway. I hope you enjoyed it. I hope you got a lot of value from it. If no one else loves you, Hank loves you. Love, peace, and chicken grease. I'll see you in the next video. Later. Yo, what up? Welcome back to your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker / network and system protector. That's going to be like a new addition to the intro here. Today we are going through phishing emails in action, which from what I understand, we're just going to be looking at a variety of different phishing emails and analyzing them to break them down and see, you know, how they're set up and what they do, how they take exploits into a new level with phishing. This is all a part of the phishing module here. that's a part of the SOC Level 1 pathway of TryHackMe. And as you can see right here, there are literally a bunch of different types of emails. So the cancel your PayPal, order, track your package, select your email provider to view document, please update your payment details, your recent purchase, DHL Express Courier. So these are actual phishing emails that have been used before that we're going to go into and try to analyze, see what they look like in action. If you are studying for your security analyst or Pentest Plus or ethical hacker certifications, I do welcome you and encourage you to like, subscribe, and turn on the notification bell of this channel. Everything that we talk about here is about ethical hacking and pen testing, and you will be learning a lot if you're trying to take these certification exams or if you're trying to do these things for your day-to-day as a job of a cybersecurity analyst or a pen tester, and they apply directly to all of those things. And I do answer all the questions and comments that come in, and sometimes I'll even maybe make a video if your question is complicated enough that requires a longer answer than I can do inside a comment section. And just as a kind of like an extra bonus, we have an amazing community of a lot of great people who are trying to get along the same exact path that you and I are going through right now. So it would be nice to have you as a part of that community so we can grow together, learn together, and become cybersecurity professionals and ethical hackers together. Now, without further ado, let's jump into the introduction of the room. Now that we have covered the basics in the first phishing email video, which is already live by the time that this goes out, the other one should be out. So if you haven't seen that one, you should go watch that one so you can see what's going on with that, for the basics of phishing emails from the perspective of the security analyst. Because I've done phishing email videos from the perspective of the attacker, of the penetration tester, but we did one from the perspective of the security analyst, and that was actually pretty eye-opening as well. So you should watch that before we go into this one. Now we're going to go into some examples. So that's really basically the introduction here, and we can move on with it. There's no question that needs to be answered or anything. So let's go into the first email, which is cancel your PayPal order. The email sample in this task highlights spoofed email addresses, the URL shortening services, and HTML to impersonate a legitimate brand. And the email recipient address is unusual in this case. It's not the email address associated with the actual Yahoo account. The mismatch could immediately stand out. The sender's details, which is service@paypal.com, don't match the sender's email address, which is gibberish at sultanbogor.com. Then you have the subject line hints that you can make a purchase or a transaction of some sort, and if you don't recall that, then it'll obviously be a red flag to you. So this social engineering tactic is to prompt you to interact with the email quickly because you probably didn't put an PayPal order, and now you need to figure out what's going on, so on and so forth. So this one is obviously not the same. The subject doesn't say cancel your PayPal order. In this one, the subject says your recipient or your receipt for payment to amazing stuff. And so you look at that, you're like, what payment? I didn't make a payment. And then you open the email immediately and you see that there's a lot of crazy things going on. So service@PayPal is what it looks like as the supposed email, which is what they put as their name. Basically, they put service@paypal.com. But then when you look at the actual email, this is definite. I mean, this looks like a scammy email. So that's really concerning. And then two, this is not the person's email, I don't think. This doesn't look like anybody's email that they would be receiving to. So the first few sections right here immediately raise red flags. And then thankfully, in this particular case, it says, for your security, we disabled all images. If you believe that it's safe to use, mark it as not spam. So this specifically is in the Yahoo spam folder, as we can see on the right side over here. And it's already been filtered out as spam because there's just so many things about it that are red flags. So if we look at the email body, there's an image right here that's been canceled out. The transaction ID, they blurred it out. So I guess that might be a legitimate transaction ID. It says, hey customer, you sent a payment of $120 to Amazing Stuff Help Center at such and such email address. And it may take a few moments for the transaction to appear in your account. So this is to, just in case they don't already see it in their credit card application or their bank card application. They're like, it's going to take a few moments. So
it's kind of in limbo that they may have received this email. The merchant information looks really legit. The setup of this thing looks very legit. This looks very much like an actual PayPal email that came in for an order. And this is, I mean, just by looking at it, if you don't know that if you kind of glance over these things, or you don't pay attention to the top portion of this, this looks very, very concerning. And so the second half of the image is at the bottom right here that has these things, and this piece right here is where that hyperlink to either exploit your machine or do anything like that comes in, because you want to click cancel the order because you didn't place the order, so you want to stop the order from going through. But by clicking that is where you actually get hooked, and where your machine will either receive malware, or they get a kind of like a remote connection into your machine, and they can do a lot of things that way. So this is a very well thought out email address, or email specific phishing email that's happening. And the copyright message at the bottom looks very legit. So there's so many things that is amazing as far as the design of the email itself is concerned. So the email body complements the sender information and the subject line. The email was designed as a legitimate email from PayPal. There aren't any attachments associated. The only interactive element is the cancel the order button link. And if we looked at it, this is it. So cancel the order, https is.gd such and such, and this is not going to eBay, or excuse me, PayPal. Yeah, it's not going to eBay or PayPal, wherever the purchase was done. It seems like, was it an eBay order? It doesn't seem like it was an eBay order, but it doesn't seem like it's going to any actual vendor. So it doesn't go to Amazing Stuff, the website, or anything like that. So the URL uses a shortening service, and it's not a good idea to click on it if you don't know where it's taking you to. So there are online tools that you can use to check this out, and this is actually very cool, that you can go to a place, screenshot of the distant page behind your URL, which is taking you over here, I guess, and you can expand it. So I guess it would, a URL shortener, and then you can have a URL expander that you can just Google to. It directs to google.com. The tools expand shorten URLs will be discussed in the phishing emails 3 room, so we're going to talk about that in the next room. But it's very, very, very well designed email, so it's kind of crazy to think about. So what phrase does the gibberish sender email start with? Is right here. It says no reply. That's the phrase that starts with, and so no reply is in their email address. All right, cool. So that was the one to cancel your order. Now let's look at track your package. Track your package. In this case, we also have a spoofed email address. We have pixel tracking, link manipulation, the email is tailored to appear that it's sent from a mail distribution center. The subject line adds the pretense that there's a tracking number here, and the link in the email body matches the subject line. So you have track your package. So this is the part, that's the subject. The email address here actually looks way more normal than the last email address that we saw, and it looks like it's coming from distribution center and it's being sent to the person. Obviously this was filtered by spam. The link itself is this thing right here. So this is a clickable link right here. Yahoo blocked the images from automatically loading. Any guesses as to why? Because they're probably malicious, right? So if we were to, you can cursor or hover our cursor over a link to see where it's pointing to, but in this example it won't work because Yahoo disabled the link. So we will look at the raw code to see what's going on. And so this is the ahref hyperlink code that takes you to this particular place, and then the image source is also going to that place, and it makes it look like a real image. So I guess they use the tracking PNG instead of the actual hyperlink or text. They used an image in that case. And we can see an image file. It's explicitly calling tracking PNG. These trackers send information back to the spammer's server. There are many reasons for spammers to embed tracking pixels, which is very small images, into their spam emails. and we'll refer to this on The Verge here if we wanted to go read about that. It's a blog called The Verge, and you can go check that out. The title is How to Stop Your Emails from Being Tracked. Then we have, we can understand why Yahoo automatically blocked it, because, I mean, it's malicious. So back to the hyperlink, the link is pointing to a shady looking domain. The only distribution center this domain can be associated with is malware, but further analysis is the only way that we can confirm that. So what is the root domain for each URL? And we need to defang it. And that is the devret.xyz. So it would be devret and then square brackets like this and then XYZ. That's how you defang a URL. And that was it for this one. So let's move on to the next one, which is select your email provider to view document. This particular email has a few other things. So there's urgency, of course, HTML to impersonate a legitimate brand, link manipulation, credential harvesting, and poor grammar and typos. That is always funny to me when they send an email and they have really bad grammar and they're trying to pretend to be an established organization. It's like, bruh, get out of here. It's so funny because I've received so many freaking spam emails and phishing emails. And before I even started studying cybersecurity, it just obviously looked really shady and suspicious. But after going through these things, I'm like, dude. And then every time I get a new one, I'm just like, my God. And recently, when I've been getting a lot of text messages coming in from these people, I just play along just to see how far I can take their con. And it's funny because eventually they learn that they're like, oh shit, this guy's fucking with us. Like, he's not an actual person that we can mess with. And he's trying to waste our time. So they just move on and they stop messaging me, which is kind of ideal. But I wanna get to the point where I can send them a link that if they click on it, they'll, I'll be able to hook their devices and get on their system. So that's kind of the ultimate goal, to like reverse spam or reverse scam somebody who's trying to scam me. Okay, moving on. So a closer look at this thing. The thing has been sent on Thursday, 1:35 p.m. I guess that's kind of an issue. Is that an issue? And what day? I don't know what day it is because it doesn't tell me. Oh, I see. So it was sent on Thursday, July 15, 2021, and expires July 15, 2021. So it expires on the day that it was sent. So that's kind of interesting. Download the document is the clickable place that you're going to probably have an attached malware or some kind of bad link. And then if we, the email was sent on Thursday, we saw that, a sense of urgency because it's sent on the same day. Notice the link to download the fax document expires on the same day. It's an action to perform, right? In this case, a button to download the fax. And if you click on it, I guess they clicked on it in this case, it took them to app.popped.in landing such and such, and then get document or preview the fax. And then if we click on it, it asks us to sign in with Outlook or any of these things, which probably means that they're going to track our keystrokes and capture our information. So that is a big deal here. So this image above shows the victim is redirected to a page created to pass as OneDrive, and the URL is nothing that is Microsoft related. So it's supposed to look like a Microsoft page, but there's nothing about it that's Microsoft related. And there are two more links for the victim to interact with. So if you click on either one, then it brings you to this other page right here, and it's directed to another site crafted to resemble Adobe, and the URL again does not look like an Adobe page, right? So it says it's SharePoint, but it's not Adobe. This is, I mean, it's very comprehensive. It's like very elaborate, this scam that they run. So also notice the page title in the tab. It's called SharePoint Online, which is a Microsoft product and it's not an Adobe product. So there are a couple of grammatical errors as well on here. So let's find the grammatical errors. To read the document, please enter with the valid email credentials that this file was sent to. Okay, sign in with Outlook, with Office 365. Select your email provider to view document. Okay, I guess this doesn't, this part of it doesn't really seem that big of a deal. then they are directed to yet another site, which was crafted to resemble Adobe again, which is the one down here. It doesn't look like it's related to Adobe, and the page title in the tab is called SharePoint Online, which is a Microsoft product. And there's a couple of grammatical errors here as well. And the victim has options to sign in with the email provider of their choice. They choose to sign in with, oh, this is up here, this part right here. Then we choose to use Outlook, for example. And if you want to, again, the link is still the bad link. The victim chose to log in with Outlook. To read the document, please enter valid email credentials, so on and so forth. And then it says invalid credentials, which is also misspelled, and or not misspelled, but the formatting of it is a little bit funky. In this example, we can tell that fake credentials were entered, but even if the victim would have entered their valid credentials, the error message would be the same. This scenario happens because the victim is not really authenticating. Instead, the credentials were entered now reside on the criminal server because they were capturing their credentials. So more grammatical errors. All this work that they put into this, you would think that they could run a spell check. So the email sample was obtained from any run. If you want to interact with the email and see the full analysis, you could go to that link below, which is on any run's website. And so if we do that, it opens it up over here, and it's a task on any run. Wow, look at this. This is it. Any run is actually a really great website, and you can also just go and watch kind of what it looks like. And if I zoom over certain things, it'll open it up and it'll show certain pieces of it. Oh, it's actually right here. So this is it. And then we move forward. So this, you move forward, and then move forward, and then move forward, move forward, move forward, da 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 da, like that. So it's pretty cool website. That is for any run. So now it says the email sample used the names of a few major companies, their products, and logos such as OneDrive and Adobe. What other company name was used in this phishing email? So we have Outlook. We have, what do we have? We have Office 365, Adobe, OneDrive, PDF. What else do we have here that might be kind of shady? Citrix attachments. So it could be Citrix. So let's see if it's Citrix. Yes, it is. All right, so there was that one. This was a pretty elaborate email right here. Let's move on to the next one. Please update your payment details. In this one, we are going to be looking at a spoofed email address, urgency, HTML to impersonate a legitimate brand, poor grammar and typos, and attachments. So there are quick observations. The email is made to appear that it's from Netflix billing, but the address is completely false. The element of urgency, again, so Netflix ID is suspended. That's what makes it urgent. There is more of this sense of urgency in the email body. And in the email body, it says right here, your account is on hold. Also notice the different misspellings of the word Netflix. So let's see. Oh yeah, Netflix, obviously in the title, as well as Netflix billing is misspelled. Not sure what the purpose of that was, honestly. Same here. I have no idea why they would do that. Typically, you'll see this technique when it comes to typo squatting, but that wasn't the case here. Typo squatting is when you want it to look like something legit and you purposefully misspell it. So, for example, making the name Alan instead of two L's, there would be one L and the number 1, just to impersonate Alan when somebody's scanning through something. But in this case, it doesn't make sense why they would do that. So it's kind of weird. And the meat and potatoes is this piece right here. So, hey, customer, we're having some trouble with your current billing information. Please open the file, PDF to update your account, which is retarded. No company would ever send you a PDF to update your account. We're here if you need it. Visit the help center or contact us now. And they have a phone number that is not, I mean, I really doubt that Netflix, unless you're in this country code or something, their phone number isn't going to be like that. It's going to be some kind of an 800 number. Please do not reply to this email as we're unable to respond from this email address. If you need help or would like to contact us, please visit our help center at help.netflix.com, which is another clickable link that you can go to. And then they have the PDF. So if you open up the PDF, this is what it's going to look like. The update payment account, my God. If you did not ask to reset your password, you may want to review your recent account access for any unusual activity. We're here to help if you need it. Visit the help center or contact us. Again, clickable links. Nobody would ever send this to you. This is insane. Notice the phone number. At first glance, this is an unusual phone number to send to a US-based victim, obviously. The attachment contains an embedded link for update payment account, and it's probably going to be a bad link. So we'll look at this email attachment in closer detail in the next room. So what should the user do if they receive a suspicious email or text message claiming to be from Netflix? So we have a hint here that's pointing us to the Consumer Affairs website. And police warn of new Netflix email phishing scam. And so beware of the links. And so what does it say? It says, what should you do? So users who receive suspicious email claiming to be Netflix are advised to forward the message to phishing@netflix.com. So we're just going to copy this piece right here. I do not want to do this pop-up. You guys are annoying with your pop-ups. And we're going to now go and paste that here. Forward the message to phishing@Netflix so that they can be caught. And now moving on to the next one, your recent purchase email. This particular email will highlight spoofed email addresses. Recipient is BCC'd, blind carbon copied, urgency, poor grammar and typos, attachments. So pretty similar to some of the other ones. The observations about this email are, let's look at it ourselves. So this is action required. So there's urgency in here. Your recent purchase of Double Jackpot Slots Las Vegas on the App Store, which is a game purchase. Then you have the Apple support being the name that's supposed to come from, but it says do not reply, store mail, yada, 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 add a different domain name. And then no reply, payment, so payment is misspelled, at app.apple.iud, yada, yada, yada. So this is just very concerning. Noticeable typos in both the sender and email addresses, do not reply and payment. Oh, do no reply, I see. So it says do no reply, it doesn't even say do not reply. This particular email doesn't necessarily have an email body, it's just totally blank, and it contains an attachment. So it makes you want to kind of just download that, I guess. And if you open it, it's a dot file and associated with Microsoft Word, and it opens it up like so, and it's basically a receipt, right? And it looks like a legitimate receipt. It even has save 3% on your Apple purchases with the Apple Card, apply and use in minutes. They do the most with this, right? What's contained within the attachment, you can see that the file contains a large image to resemble an Apple Store receipt, and then the link contains certain keywords related to the Apple, which is apps and iOS. And this entire thing is not text, so none of this is text. This whole thing is just one big image. So it was created and then pasted inside the document. So BCC is blind carbon copy. And the technique that was used to persuade the victim to not ignore the email and act swiftly is urgency. And that is it for the recent purchase one. And now we can move into the DHL Express courier shipping notice. DHL Express courier shipping involves a spoofed email address, HTML to impersonate a legitimate brand, attachments, and so we look at here, right? So DHL Express, info@glamcarcompany, definitely not the email. DHL Express courier shipping notice with the tracking number, not a tracking number, I think that's the notice number, or maybe the shipping order ID, something like that. It doesn't look like a tracking number. Then they used their actual header for their company, which looks very, very real. Thank you for scheduling a courier shipment with DHL. Look at the source code for the email. Oh, I see, that's not part of the email. Looking at the source code for the email, the link to view the email as a web page doesn't contain an actual destination URL. So to view this email as a web page, go here. There's nothing there for them to go to, which is this thing at the top right here. The only element that they can interact with is the attachment, which in this case is an Excel document. And when that opens up, we have this thing looking here that is, I don't know, Chinese or Japanese, I can't tell, but it's definitely not English. And the attachment runs a payload that throws an error. Ooh, so there's macros inside of this particular attachment, or excuse me, there's a payload that's inside the macros of this attachment. Macros is source code of a document like Word document or an Excel document that you don't see. Like the metadata is stored inside the macros, so you can store something inside of the macros. And in this case, it says C users admin app data roaming regasms.exe. The NTVD CPU has encountered an illegal instruction. Click close to terminate the application. So they tried to do something, and thankfully the computer caught it in this case. So very, very interesting. In this case, what is the name of the executable that the Excel attachment attempts to run? And it is regasms. Regasms.exe. Very interesting. Very, very, very interesting. And that's the last one, actually. So now we can just go into the conclusion, which basically says we looked at previous phishing emails or various phishing emails. Some of the samples shared similar techniques, whereas others introduced a new tactic. Understanding how to detect these things takes awareness training. So you got to train the employees and keep this in front of them all the time. Share anything that happens and new developments and new case studies all the time so that they know what's going on. Additional resources are these links right here. So we have KnowBe4, IT governance, cheap SSL security, and phishing quiz with google.com. And we're going to be looking at phishing emails 3 in the next one, which seems like we're going to be looking at more of the tools for it. Let's see what that actually is. So phishing emails 3 is going to be the phishing analysis tools is going to be the next room that we're going to go into. So it should be fun. Should be an interesting thing. The deeper that we go into this, the more we learn, and there are better tools to use. So this is one of those things that we're going to run across a lot as cybersecurity analysts, because this is the weakest link in the chain, is the humans in the organization. So attackers are more likely going to target the humans, the workers, the professionals, the employees, the peers that you have, whereas trying to attack the systems, because the systems constantly get patched. And if you have up-to-date systems, more likely you're going to be fine. So it's getting the human beings is going to be the strategy to be able to do that. So that's it for the phishing emails in action room that we're in. If you're studying for your Pentest Plus or Ethical Hacker or Security Analyst certification, any of those things, I will encourage and welcome you to like and subscribe and turn on the notification bell and drop a comment, all that stuff. I respond to all the comments, and if you have any questions, I'll definitely answer your questions in the comments as well. I might even make a video for you. Yeah, it would be just lovely to have you as a part of our community. I think it would be really awesome to have somebody else to keep adding awesome additions to our community that is growing like weeds. And it's been very, very cool, and it's been very humbling of an experience to have everybody hop on board with us. And I consider it to be a privilege. So I would love to have you as a part of our community. I think you will get a lot of value from it. And the videos from this channel are all focused on cybersecurity and ethical hacking, penetration testing, all that stuff. So I think it'll be useful to you in your path of becoming a pen tester or cybersecurity analyst. And I would love to have you as a part of the community. So that being said, we are done with this. This has been your boy, Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker / protector. And yeah, if no one else loves you, Hank loves you. Love, peace, and chicken grease. I will see you in the next room later. What's going on? It's your boy, Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker / protector. And today's video is about phishing prevention. So we looked at a lot of different or not a lot of different, but we did a good series of analysis videos so far. So we did the analysis fundamentals, where we're doing manual analysis. We looked at some examples of phishing emails in the emails in action video. And the last one was about phishing analysis tools to help you automate analyzing phishing emails. And today we're talking about phishing prevention. And then the last one is going to be the Greenholt Phish, which is us. It's like a live case study where we actually analyze a phishing email. And this is all a part of the phishing module that is part of the SOC Level 1 pathway of TryHackMe. And this is the content outline for this particular video. So obviously we have the intro, then there's the sender policy framework, the DKIM domain keys identified mail, DMARC, domain-based message authentication, reporting, and conformance. And then we have S/MIME, secure multipurpose internet mail extensions, SMTP status codes, SMTP traffic analysis, SMTP and CNC communication, and then finally the conclusion. All of this stuff is going to be time-stamped in the description below. So if you need to skip back and forth between any of these things, the timestamps are below. And yeah, that's pretty much it for the outline of the room. If you are studying for your SOC Level 1 or Security Analyst, Ethical Hacker, Pentest Plus, all that stuff, I encourage you to like, subscribe, and turn on that notification bell so that you get notified the next time that a video comes out, especially if you're studying for any of those certifications. Literally all of the videos on this channel are either about security analysis, ethical hacking, pen testing. So it all directly applies to your examinations, your certification exams, but then on a day-to-day, whatever you do on a day-to-day basis in those jobs, this is also applicable to all of the stuff that you do on your day-to-day. So I think it's useful on both ends, both for the certifications and for the day-to-day activities that you would be doing in any of those roles. And, you know, on top of that, as an extra bonus, it would just be really awesome to have you as a part of the community. And we have a beautiful, growing community of a bunch of really awesome people from all over the world who are all trying to become ethical hackers and security analysts. So it would be lovely and amazing and awesome to have you as a part of our community. That being said, without further ado, let us jump into the introduction of this room. There are various actions that us as defenders can take to protect the users from falling victim to a malicious email. And some of these are listed here. So we have the email security, spam filters, email labels, email address, domain URL blocking, attachment blocking, attachment sandboxing, and security awareness training. In my opinion, this is actually the most important one. But a lot of these things are really, really important. So for example, setting up some type of a pre-configured automated process where anything that comes through your domain email servers is going through a sandbox type of an environment or some kind of filtration environment, so that if anything gets opened, it detonates inside a sandbox environment to detect malicious activity, or blocking the emails based on either extension of the attachment or just certain IP addresses or domain names or any of these things. It's very, very useful to be able to set up all of these pre-configured stuff, but none of that, in my opinion, none of that can be greater and more powerful than a properly trained employee roster, where they understand to look out for these things themselves, and they're kind of the first level of security. And if they don't click on any of this stuff, then you don't have to worry about it. You know what I mean? If they forward you the email, all of that stuff, it becomes an extra layer of security that, in my opinion, can honestly end up being invaluable. It can be priceless. So these are just some of the actions that we can take as defenders to protect the organization or the network from falling victim to phishing and malicious email. Per MITRE attack, phishing for information is described as an attempt to trick targets into divulging information and contains 3 sub-techniques. And then we have, if we look at the above link right here, we can go under mitigation under software configuration. So right here, mitigations under software configuration. And we can look at what these things are. And specifically, it's for the software configuration, use anti-spoofing and email authentication to filter messages and integrity of messages. Enabling these mechanisms may enable recipients to perform similar message filtering and validation. And then you have user training, then you have the detection, so on and so forth. So this is, I think it's kind of an overview type of thing. It's not very detail oriented, but if we clicked on software mitigation, obviously it just takes us further into the different ways that you can mitigate against software stuff. So this is the detail stuff that you want to be looking at. And you know, this is extra credit reading. We're not going to go into this right now, but this is a good source for you to know, be aware of. And this is all through MITRE ATT&CK framework. MITRE ATT&CK framework has a lot of amazing stuff for a lot of different types of attacks and advanced persistent threats and tactics and techniques and procedures and a lot of these things that you can go and look at. And a lot of these things have been pulled from real life scenarios that have happened before that are now in their database. So very, very important for you to consider. And then in this room, we're just going to specifically focus on email security from the actions that have been noted above. And after visiting the link, what is the MITRE ID for software configuration? It's literally right on the screen right here too. But that's the MID, M1054, and that's for software configuration mitigation technique. So that's basically it for our intro. Let's jump into the sender policy framework. SPF per Demarchian is used to authenticate the sender of an email. With an SPF record in place, internet service providers can verify that a mail server is authorized to send email for a specific domain. An SPF record is a DNS-TXT record containing a list of the IP addresses that are allowed to send email on behalf of your domain. So this is what it looks like visually. It's the workflow for SPF, right? So the sender sends the email, the organization's email server is what it filters through. So it goes to the email server sends it to the recipient's email server. And then from this section, there's this back and forth process where the recipient's email server goes and sends the sender's ID framework and SPF record lookup to see against the sending organization's DNF server and if there are any published SPF records. And if they are, it just sends all that information back and then it gets authenticated. If it's not authenticated, it gets rejected. And once it's authenticated, it can go to the reputation database and then it gets sent to the recipient's inbox. So it goes through this database that has already been established, these records that have already been established to check to see if it's all good. If it's all good, it gets authenticated. If it's not, it gets sent to the spam folder. And this all happens probably within a matter of a few seconds, if that. And it all happens in the background. We don't see any of this stuff. All you see is just your spam folder gets filled up with things. So that's kind of the workflow of what happens with the SPF, the Sender Policy Framework. It's, credit to Demarchian. How does the basic SPF record look like? So you have V equals SPF1, the IP address, which is IP4, is the local IP, and this is for every local machine. It has the same exact IP address. It includes, spf.google.com, all of those things. And so the explanation is the start of the SPF record is V equals SPF1. This is the IP, which in this case is IPv4, not 6, and it's the IP that can send the email in this case. It includes which domain can send the email, which is SPF Google, and then non-authorized emails will be rejected. So all of the non-authorized emails will be rejected outside of this thing, right? So it includes this, and then everything else will be rejected. To the record syntax on Demarchian could be referred to in this email. We have, or not this, this link, and this is the syntax table from Demarchian. I'm not sure if that's how you pronounce that. Now we have another link as well, which is what is the difference between SPF all and all. So there's a squiggly line and then the dash, and then all of that could be read as well. And then this is a soft fail in case of, and then fail in case of this. So this is the soft fail and this is the, I guess, the hard fail. So we have those two. I'll keep those open just in case we need to refer back to them. Looking at Twitter's SPF record using Demarchian's SPF surveyor tool, we can look at that. So right here, look at that. So we can see this. So we can do, let's say, tryhackme.com in this case, and then look at high five, your SPF record is valid, but we notice that you don't have a demarcing account, whatever, and this is TryHackMe's SPF record. And then you can see all of that here. And then of course, it's valid, so that's always a good thing. For Twitter, they got a 7 out of 10 DNS querying mechanism modifier to resolve the record. 58 net blocks are authorized, and we can refer to this to create our own SPF records if we wanted to. Another example would be the Google Admin Toolbox message header, which was, we used it in the last video to kind of auto-analyze certain emails. And then you can also see the SPF portion of the message header to see whether or not it's known or unknown, and if there's a soft fail or an actual fail. And that information can also be referenced. So all of these things, this can end up ultimately becoming an entire department inside a large organization, where they literally have just a phishing department for like email security department. Because a lot of these things, you can imagine how much spam or how much malicious email Google is probably getting, you know what I mean? So the above images shows that the status of the SPF record check, it reports back as a soft fail, which is the squiggly line. Even though this task uses demarcing for SPF related information, many other companies do the same thing. So referencing the demarcing SPF syntax table, what prefix character can be added to the all mechanism to ensure a soft fail? And that was the squiggly line, so that thing. And then we have, what is the meaning of the all tag? So the all tag is deny, I think, that's what that means. So we have, will be rejected. We can look at the actual definition here. So if we look at, let's look for specifically -all, and it's not pass. So fast forward to the demarcing to find any positive assertion. In this text, all is the same thing as all, not pass. I don't think that's it though. So let's see what else we can find. Okay, so it's actually failed. That was kind of a guess, but since the squiggly line means soft fail, the regular dash would mean fail. And that's what we got here. So that is all good. And we are now officially finished with task 2 for the Sender Policy Framework SPF. And now we can move on to the Domain Keys Identified Mail DKIM. DKIM per demarcing. It stands for Domain Keys Identified Mail and is used for the authentication of an email that is being sent. Like SPF, DKIM is an open standard for email authentication that is used for DMARC alignment. DKIM records exist in the DNS, but it's a bit more complicated than SPF. The DKIM's advantage is that it can survive forwarding, which makes it superior to SPF and a foundation for securing your email. So it looks like this, and I'm not even going to try to break this down, but we have some key portions of this. So you have the VDKIM, which is the version of the DKIM record. We have K equals RSA, and this is the key type. RSA is real security algorithm, and it's an encryption algorithm. And then you have P equals the public key that will be matched. So for the most part, this is the last piece. That's the last variable. You have V and then K and then P. So that's pretty much it. And we can look at the resource here for more information. So this is the DKIM selectors, and then we also have this for the DNS record overview through validity. You have DKIM pass in this one, where this is from an email header that has been flagged as spam that contain a potentially malicious attachment. So I guess in this case, pass means, you know, move on, not let through, right? So which email header shows the status of whether DKIM passed or failed, and I believe that would be authentication results. So let's try that. And that is correct. So we have authentication results. Let us now move on to the DMARC, domain-based message authentication, reporting, and conformance. Per demarcing, domain-based method authentication, reporting, and conformance is an open source standard, uses a concept called alignment to tie the result of two other open source standards, and SPF, a published list of servers that are authorized to send email on behalf of the domain, and DKIM, a tamper-evident domain seal associated with a piece of email to the content of an email. If not already deployed, putting a DMARC record into place for your domain will give you feedback that will allow you to troubleshoot your SPF and DKIM configurations if necessary. So how does it look like? This is what the query looks like, and you have P for quarantine. So we can just look at it like this, right? So DMARC 1 has to be in caps, and it's not optional to not be in caps, so it has to be in caps. And then we have the quarantine. If a check fails, then an email will be sent to the spam folder, otherwise being quarantined. And then you have the RUA, so mail to postmaster, so on and so forth. Aggregate reports will be sent to this email address. Refer to DMARC resources here and here for additional information. And we can look at those here. So DKIM, this is from Validity, and then this is from DMARCian itself. And then we still have the DMARC overview that's available here. And I'm just building out a bunch of links here, so I'm gonna close these out before they get out of hand. And we will go into the rest of this stuff. So we have DMARC resources, okay, and then the domain health checker from dmarcian.com, and check the DMARC status of Microsoft.com. So we're gonna go here, domain health checker, and we're gonna go look at Microsoft.com, and we're gonna check the domain, and the results are your domain is protected against abuse by phishers and spammers. It gives us some of this information. Microsoft passed all the checks. We can drill down DMARC SPF TKIM to get more details, and then it this is what it gives us as the details underneath that. So in the details above, we can see that all the emails that fail the DMARC check will be rejected. And which DMARC policy would you use not to accept an email if the message fails DMARC check? So I kind of cheated for this one and actually Googled the question, and I think it's P equals reject. So if we do P equals reject, okay, there it is. Because when I went to search for it inside of the links that they gave us here, I couldn't find anything relevant to that, or maybe I just didn't look close enough, but I couldn't find it here, and I was just trying to make sure that I get the information quickly, so I ended up Googling it, which, by the way, is not against the rules. There is a lot, they say a lot of times in a lot of these labs that, you know, you're more than welcome to use your own resources to find these answers, and what we're looking for is the answer, and in this case, I used Google to get the answer because it wasn't available on this page. Maybe it is available on this page, but I didn't pay attention closely enough because I was really trying to get the answer quickly. It is Friday night as I'm recording this, so I'm on a little bit of a time crunch. I hope you won't judge me for that. But even if you do, then, you know, whatever, judge me all you want. I don't care. So let's now move into the next one, which is the secure multi-purpose internet mail extensions. All right, so what is SMIME? Secure multi-purpose internet mail extensions is a widely accepted protocol for sending digitally signed and encrypted messages. As you can tell from the definition, the two main ingredients are digital signatures and encryption. So for sending digitally signed and encrypted messages, we see that. So using the public key cryptography, which is from IBM, this is the definition that they got over here. The SMIME guarantees data integrity and non-repudiation. If Bob wishes to use SMIME, then he'll need a digital certificate. The digital certificate will contain his public key. With his digital certificate, Bob can sign the email with his private key. Then Mary can then decrypt Bob's message with Bob's public key. And Mary will do the same, send her certificate to Bob when she replies to his email, and Bob completes the same process on his end. Both will now have each other's certificates for future correspondence. So this is what it looks like. Bob sends a plain text email, and it uses Bob's private key to encrypt it, and so then the encrypted email goes through ciphertext, and his private key is used to decrypt it by Mary, and she looks at it on her side as an as a plain text email. But as it transfers, as it goes across the cloud, right, it is encrypted and it's ciphertext, so people can't man in the middle it or intercept it and get some juicy information out of there. So refer to the documentation for more information on SMIME and how to figure out the Office, how to configure Office 365 to send, receive SMIME emails. And we probably need to use this. What is non-repudiation? The answer is a full sentence, including the period at the end. And whose description do we need? We need the Microsoft description. So let's go here and try to find non-repudiation. The uniqueness of a signature prevents the owner of a signature from disowning the signature. I think that's what it's called. So we're going to take this whole thing, the uniqueness of yada yada yada, including the period at the end, because we have good grammar. And we're going to go here and we're going to paste that, and that'll be our answer. So there we go, we got it. And now we can move on to the SMTP status codes, excuse me. For this one, we started a virtual machine and it's almost ready to go. And so we're going to be examining a PCAP file with SMTP traffic, and we're only going to focus on the SMTP codes in this task. We got to be familiar with Wireshark, so if you haven't messed with Wireshark or used Wireshark, this might be a little bit over your head. There are a lot of videos on Wireshark. I have a 2.5-hour tutorial on Wireshark and a few other videos as well, so you're more than welcome to go check those out. And the two resources that we need to assist with this task is going to be the Wireshark documentation and mailer sender SMTP codes. And we're going to try to see what we can find. So there's the PCAP file. It's right on the desktop. I'm going to open that up, and that's going to give us a couple of seconds here. So it's asking us, what Wireshark filter can you use to narrow down the packet output using SMTP status codes? Per the network traffic, what was the message for the status code 220? Do not include the status code. One packet shows a response that an email was blocked using spamhouse.org. What was the packet number and status code? And then based on the packet from the previous question, what was the message regarding the mailbox, and what is the status code that typically precede an SMTP data command? So here we go. This is what we got here. I'm going to open this up in a full screen just to make it a little bit easier to navigate. And so we can go full screen with that. I'm also going to open up these documentations that we can use, and we'll start from the very top. So what Wireshark filter can you use to narrow down the packet output using SMTP status codes? So let's look at that. Okay, so that was right down here at the bottom. There's one that is called SMTP response code, and then we're looking at response code right here, and that is it. That gives us the packet output using status codes. So per the network traffic, what was the message for status code 220? So do not include the status code in the answer. So we're going to go filter this SMTP status code, and then we're going to look at the message 220. So let's see. Where is it? I'll bring this closer to us here, and we'll go full zoom with this thing, or full screen with this thing. And we're going to go to SMTP status or response. I think that's what it was, right? Response? Yeah, response code. Response code equals 220. See what we get. So there we go. And so it's asking us, what was the message? What was the message for status code 220? Do not include the status code. Oh, I see. I think it's right here. So response code, domain, service ready, and that's for 220. So it says do not include the 220. So domain, service ready. Yeah, there it is. Okay, so one packet shows a response that an email was blocked using spamhouse.org. Let's copy this, and then let's go search for that. It says what were the packet number and status code? So let's try to search for spamhouse.org in all of this stuff here. Okay, so I removed the filter at the top, and I did Control F to find and then I clicked in the drop down right here. Usually it comes out with display filter as the main option, and you want to change that to string so you can search for string. And then we searched for spamhaus.org, and it automatically highlights the packet we're on. And then it also gives us the response right here. So email blocked using spamhaus.org. So its response is 553 and the frame is 156. So we want, which one we want? 156 and then 553. And based on the packet from that question, what was the message regarding the mailbox? So let's look at this. And what do we want regarding the mailbox? Mailbox name not allowed. That's what it is. So mailbox name not allowed. And then what is the status code that will typically precede an SMTP data command? So based on the hint, it says the server is now waiting for the body of the message. And I went to the SMTP codes and I searched for body on the screen, and it's right here. So the email header has been received. The server is now waiting for the body of the message, and that is status 354. And just like that, we have all of our answers. So that is it for this one. So SMTP status codes, and then let's see if we have another one that, yeah, we're going to be using the same thing from the virtual machine, I think. So let's go into the SMTP traffic analysis. All right, so the first question is, what port is the SMTP traffic using? This should already be 25, so that should be automatic. There we go. That is 25. How many packets are specifically SMTP? So let's go to, here's our browser right here. I'm going to cancel this out. This is a very slow machine. It's taking forever to close things out and do all these things. So specifically SMTP, I'm just going to type that and then press enter and see how many we get at the displayed portion at the bottom right here. So we have 512 SMTP packets. So let's see if that's the right number. Very good. What is the source IP address for all of the SMTP traffic? So the source IP address for all of the SMTP traffic, this seems to be interesting. So let's change, or let's see if we can design a nice parameter here to find the source IP address. Okay, well that is really weird, because that is not the source IP address. That's actually the destination IP address. And so what I did is I did SMTP, and so you do 2 ampersands, and then I just used the SMTP response code for 220 for just to get a successful response. And all the destination addresses are the same, but all the source addresses, or most of the source addresses, are different. So that, it seems like a weird phrasing to the question, but the same one was the 10.12.19.101. That was the IP address right there. So what is the file name of the third file attachment? So that one is going to be an interesting one. So we need to find attachments. How do we find attachments? Okay, so the attachment one was actually, they gave us the thing, the link to it. So this is the link that's available right here. And when you go here, I was looking for something that would actually be specific to attachments or something like that. But IMF by itself is the internet message something. And when you do internet message format, I want to say, yes. So it is internet message format. And in all of these things, there's an internet message format section in the portion right here. And then from here, we can look at the MIME multimedia encapsulation type. And then it gives you whatever the attachment was in this particular one. So this is the first one. So let's go to the third one and then look at the same data. And it is right at the bottom right here. So you go MIME multimedia encapsulation and then encapsulation multi-part application octet stream, not the text plane. So we want to look at the application octet. and then under that there is the portion content disposition attachment, and it has file name attachment.scr. So let's try that here. There it is. And how about the last file attachment? So let's look at the last one. Same thing. We're going to go, and then we're going to go to the last one here, and then we're going to look at the file name, which seems to be .zip. I think that's the file name. Yeah, that's what it is, .zip. And there we go. So we got the SMTP traffic analysis task. So finally, let's go look at the SMTP and CNC communication task. Let's see what this one is. So this one does not seem to have a task associated with the PCAP file that we got, but we'll look at how SMTP has been abused by adversaries for C2 command and control communications. This is a MITRE attack technique 1071 sub-technique, and this is the link to it, and then we'll come back to that real quick. So adversaries may communicate using application layer protocols associated with electronic mail delivery to avoid detection network filtering by blending in with existing traffic. Commands to the remote system, and often the results of those commands will be embedded within the protocol traffic between the client and the server. Several notable groups such as APT28, APT32, and Turla have used this technique. The recommended mitigation is network intrusion detection and prevention systems, so basically NIDS or NIPS systems that use network signatures to identify traffic for specific adversary malware can be used to mitigate activity at the network level. Detection opportunity per MITRE. Analyze packet contents to detect application layer protocols that do not follow the expected protocol standards regarding syntax, structure, and any other variable adversaries that could leverage to conceal data. So this one basically says make sure your NIDS and NIPS that use network signatures to identify traffic can be used to mitigate activity at the network level. And then detection opportunity would be to analyze the packet contents to detect the application layer protocols. So this is the, I want to say this is layer 7, because if we're starting from the bottom up, so layer 1 would be the physical layer, and you go all the way up, and I think layer 7 would be the application layer protocols that do not follow the expected protocol standards regarding syntax or structure or any other variable adversaries that could use to conceal the data. So you want to analyze packet contents on the layer 7 application layer to see if there's anything out of the ordinary with syntax, structure, or any other variables that can be used. So we will cover network intrusion prevention and detection in future rooms, so we're not going to talk about that right now. And per MITRE attack, which software is associated with using SMTP and POP3 for C2 communication. So let's actually go here now, and let's try to see if we can find that. All right, so out of this entire list right here, there's only one that I can see that actually uses SMTP and POP3 for C2. Most of them say SMTP for C2. So it would be Zibrosi. I don't know if that's how you pronounce that. Zibrosi. And there it is. And we are now wrapped with this particular room. So let's jump into this conclusion real quick. Which basically says by looking, sharing at a phishing incident response playbook. So this is the phishing incident response playbook that's available through GitHub, and I am gonna see if it's. I mean, it's a good link to save. Again, I need to start creating these resource links for all of this stuff. The PCAP file in this room was from malware traffic analysis, and we can use more of their stuff using going to their index and finding more PCAPs for different malware analysis. But definitely go look at the GitHub for phishing playbook, and the specific location is right here. So counter active incident response plan template, and it can be found over here under the playbooks. And then when you go to playbooks, you can go further into and finding phishing, playbook phishing. And that's where you can find that. And yeah, that's pretty much it for this room. If you found this room useful, if you found this video useful, if you're studying for your security analyst, SOC Level 1 or ethical hacker, if you're blue teaming, if you're red teaming, any of those things, I do encourage you to like, subscribe, and turn on that notification bell so that you can notify the next time that we drop something, because everything that we talk about on this channel has to do with ethical hacking, penetration testing, network security, system security, and you can use the information here for your certification exams as well as your day-to-day activities for security analysis or pen testing, ethical hacking, all that stuff. So would love to have you as a part of the community, but I think you'll get a lot out of it. And hopefully we'll see you in the comment section. Drop all your questions, comments, anything that you got, and then I will get to your comments as fast as I possibly can. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker / protector. I hope you got value from this video. If nobody else loves you, Hank loves you. Love, peace, and chicken grease. And I'll see you in the next one. Later. Hello, welcome back. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker / protector in this case. In today's video, we're going to be going through the phishing analysis tools that are available in the phishing module for the SOC Level 1 pathway of TryHackMe. And as a part of this room, we're going to be going through a lot of good stuff. So this is kind of the general outline, right? So we have the intro, what information should we collect, email header analysis, email body analysis, malware sandbox, phish tool, and then there's a couple of cases here, and then we have our conclusion. You can refer to the individual sections for this in the timestamps below. Everything has been timestamped, so you can go through everything easier if you're trying to look for answers, or if you're trying to find certain things. If you're going through these tasks yourself, you can use them like that. And every video that I do also has timestamps, so you can find it that way. If you're studying for your SOC Level 1 or Security Analyst certification, or Pen Test Plus, or Junior Pen Tester, any of those things, then I invite you to like and subscribe and turn on that notification bell so that you get notified the next time that a video comes out. Everything that we talk about on this channel has to do with cybersecurity and pen testing and ethical hacking, all that stuff. So it'll help you directly with your certification exams, and you can use it on a day-to-day when you go to work, and most likely you'll be doing a lot of these things while you're working, and for your day-to-day job as a pen tester or ethical hacker or security analyst, any of that stuff. And plus, it would also be really nice to have you as a part of our community, and we've had a nice growth spurt in our community, so it would be amazing to have you join the gang as we learn about all of these things and we go through the journey together. So without further ado, let's jump into the introduction of this room. So from Phishing Room 1, so by now that video would already be live, and if you haven't seen that video, I recommend you watch that, because we're probably going to touch on a lot of things that we covered in that video, so it would be a good idea to have that first. We covered how to manually sift through email, source code to extract information, and in this room we're going to look at tools that are going to help us do that. So, I mean, you can technically, I guess, just watch this video, but it would be also good for you to learn how to look at raw source code in case you can't access these tools for whatever reason. So you need to know the foundations before you start using tools that do the job for you. So the tools that are going to help us examine email headers, techniques to obtain hyperlinks in emails, expand the URLs if they're shortened, look into tools that give us information about potentially malicious links without actually interacting with those links and clicking on them, and then techniques to obtain malicious attachments from emails and use malware sandboxes. This is a very important tool or strategy right here. To detonate the attachment to understand further what the attachment was designed to do. So you want to open it in a controlled environment so that it doesn't actually damage your system or your network. And that's what a sandbox is specifically designed for. These are actual spam and phishing emails, so be careful if you're gonna go to any domains or interact with any of the attachments and stuff like that. You don't want to actually do that. I would highly recommend you just either watch the video for this or go through the controlled environment with TryHackMe to do it. So let's jump into what information should we collect. This is pretty much a read-only task. There's no actual question that we need to answer at the end. And we just need to understand what steps we're going to go through when you analyze something suspicious or malicious. And this is the checklist for an analyst, which is you and me, to collect from the email header specifically. And then the email address, the IP address, so the sender email address, their IP address, reverse lookup of the IP address, subject line, the recipient email, which is probably, you know, whoever is the victim in this case. It can also be a CC or BCC, like blind carbon copy or carbon copy. And then the reply to email address, if it's different from the actual sender email address, and then the date and time. Because all of these things actually can give clues as to whether or not what you're looking at is malicious. And believe it or not, the date or time can actually play a part in that too. So after this, we're going to go to the email body and the attachments if there's anything. And this is something that we need to look at to collect from the email body. So the URL links, if there are any shorteners that are used, what the link is actually pointing to, which is a lot of times also just kind of like a, what is it? I'm drawing a blank on the word, but it's basically a diversion. There you go. Like the text in the link that they used is used as a diversion to distract you from where it's actually going to be pointing to. So the name of the attachment, the hash value of the attachment, because you can actually get the hash value of the attachment without actually opening it and running it. So right here, not to click on any links or attachments in the email accidentally. It's very important to understand. So they said that twice already. So we just need to keep that in mind. And hopefully I won't forget and to click on something and then ruin the lab environment, or I don't know what's happening, but we'll see. It just sounds really scary as they're telling us this. So let's look at email header analysis. All right, so some of the information that you need can be obtained visually from the client. So the HTML version of the email that you're looking at, so Gmail, Yahoo, all these guys, they actually show that to you. But the stuff like sender's IP address and the reply to information, if it's different than the email that is coming from, it can only be inside the email header. And so in Phishing Emails 1, we actually saw how to do this by looking through the email source code. And we can look at some tools that will help us retrieve this information. There was also some links that was available in Phishing Emails 1. I'm just going to open this just to have it here, that showed us resources, external resources outside of TryHackMe that we could use to try to find information like that. So for example, not ARPANET, let me see, it's actually here that we can use to see where these things are located. And let's see. So right here, the knowledge base article from Media Temple, which takes us to here. And then in here, they tell us what you can look for to find certain pieces of information, because it doesn't say reply to, or in the actual text itself, it doesn't say that. And again, there's another one that was available as well, that it's this one. I think, yeah, this is the one actually. So this is the one, not the first one, although this one is probably useful as well. But this one specifically, so for example, it doesn't say reply to in the source code, it'll say return path. And that's where you can find the reply to email. So when you're searching through the text, you can't find anything that would say reply to. You actually look for return path, and that's the information that gives you the email address that would be the same as the reply to email address. So I'm just going to keep this one open just in case we need to refer back to it. And then we can go back into this one right here. So per the site for Google, the message header from Google Admin Toolbox, it says message header analyzes SMTP message headers, which help identify the root cause of delivery delays. And you can detect misconfigured servers and mail routing problems. Copy and paste the entire email header and then run the analysis tool. And this is the message header tool that's available inside of Google, and it's free, and I don't even need to use my email address for this. So we're going to keep that open as well, just to be able to use some of that. Another tool is called Message Header Analyzer, that's available through, I don't know who, but This is another one right here, same thing. So I'll just keep all of those open for now, and we'll close some of these just to keep less tabs open. And again, it just shows us the message header, and then of course we have mailheader.org, which is yet another tool. And these are all free tools that you can literally just go to these links and paste stuff in there. So that's actually very useful. You don't need to have any kind of an account or anything set up, so that's always nice. Even though it wasn't discovered or discussed in the previous phishing rooms, a message transfer agent is software that transfers email between sender and recipient. We can read more about those here. Since we're on the subject, we can also talk about mail user agents, which we already discussed in the first phishing video. The option on which tool to use ultimately relies on us. It's good to have multiple resources to refer to, as they might reveal different information that some tool might not have. The tools below can help you analyze information about the sender's IP address, so we can keep that open as well. I'm just going to close one of these ones. I'll keep the Google one open, and we'll see if we need anything else. But we're going to have IP info, and we're going to have the Google admin box. And then IP info, you can pinpoint the user's location, customize their experiences, prevent fraud, ensure compliance, and so much more. And this requires a sign up from what I can tell. And let's see, they don't even have a free version of this. So I'm going to close this because I'm not going to sign up for any of that right now. Then we have urlscan.io, which is another one. Let's see if this one is free. This one seems to be free, but this scans URLs. Free service to scan and analyze websites. When a URL is submitted to URL scan, an automated process will browse the URL like a regular user and record the activity that this page navigation creates. Includes the domains and IPs contacted, resources, so on and so forth. So you can pause this and read it if you want to. But this is kind of what it looks like right here. URL scan provides a screenshot of the URL. This screenshot is provided so you don't have to navigate to the URL in question explicitly. And we can use other tools such as URL2PNG and Wanna Browser, which take a screenshot so that it's not clickable and you don't accidentally click on anything, which is actually very cool. Talos Intelligent is another tool that we used when we were going through the cyber threat intelligence modules and the rooms, and this is actually a very, very useful website as well. And you can search for a lot of stuff on here, not just IP and domain reputation, but you can literally find file reputations here, file reputations, secure endpoint naming conventions, categories. There's a lot of stuff in Talos Intelligence that we can find useful. So very, very cool. What is the official site name of the bank that Capital One tried to resemble? And that would be capital1.com. There you go. I was about to say, how's that not correct? I can already tell that this is Capital. This trying to be Capital One. So there's that. We didn't even have to look into that. I could just tell because I actually use Capital One as one of my credit card people. Moving on to email body analysis. So the email body is where malicious payloads may be delivered to the recipient in link or an attachment. Links can be extracted manually, either from the HTML formatted or sifting through the raw header. The example that we have here is from manual obtaining of a link by right-clicking on the link and then choosing copy link location. I've done this multiple times, and this is an example right here. So you have the link right here. You can do copy, right, or right-click on it, do copy link address in this case, and I just open up a new tab and I paste it, and it basically tells me what the link address is. Now in this case, it's actually the same exact link that this is, so sometimes it could be very different. So if I went to something that said click here, so CyberChef for example, this is a hyperlink, and so we can click on this, copy link address, and then go here, and then it gives us a completely different link. Look at this. This is a completely different link than what you just saw right there, and it's actually even a different link than the link for cyberchef.com, because there's literally CyberChef, or not cybersecurity. Gosh, what is going on? It is cyberchef.com is the actual link. So you have cyberchef.com. Oh my God, it's not even cyberchef.com. So maybe this is the actual link to CyberChef. Let's see. If we press enter, okay, so this is the link. This entire time I thought that it was a completely different link, but I guess that's it. I think previously what I used to do is I would just do CyberChef and then press enter, and I would just click on the link right here, and I never paid attention to where the actual URL was going. So there is that. We are now here, so let's go back to the top here. So by right-clicking on it, you can copy the link location and then open it up, and then it can be accomplished with the assistance of a tool. One tool that can aid us is the URL extractor, and you can copy and paste the raw header into the piece right here. So we can do the raw header pasted in here, and it'll give us the extraction, what's actually available to extract. So you would paste the header in here, and then from here, extract URLs are visible in step 3. So it would be step 3 right here. So choose output options. We can choose that if we want to. If not, we can just do paste it here and then do extract, and it'll actually show us what is available through all the URLs. And then we can also use CyberChef to extract the URLs by using extract URLs recipe. CyberChef is pretty amazing. It's one of the tools that we use very frequently when it comes down to security analysis, just because of all of the different quote-unquote recipes that are available that you can just do a lot with. So it's important to note that the root domain for the extracted URL, you will need to perform an analysis on the root domain as well. And after extracting the URL, the next step is to check the reputation of it, and you can use any of the tools mentioned in previous tasks to aid. If the email has an attachment, you'll need to obtain the attachment safely. Accomplishing this is easy in Thunderbird by using the save button, and in a lot of other email clients, without actually having to open it, you can just save the attachment. After you've saved it, you need to get the hash, so SHA-256 sum or MD5 sum, any of those things. You can check the file's reputation with the hash to see if it's malicious. So that is a very reliable process. And then we can use available tools like the Talos Intelligent file reputation source website that will also show us what the reputation of that file is. We can go to VirusTotal, we can go to Talos Intelligence. There's a lot of different places that will show you what the reputation of a file is based on the hash value of the file. And just like this, you can see this is the SHA file. It's malicious based on what Talos says. It gives us the detection aliases, so a bunch of different names that's been attached to this that comes with that SHA-256 hash value. VirusTotal, there we go. We're looking at it here as well, and it shows us. And VirusTotal has a measurement against a bunch of different detection software, so antivirus softwares or SIM softwares, anything like that. In this case, out of the 62, 23 of them have marked this specific hash value to be malicious. So you can rely on the fact that there's multiple places, but in my opinion, if even one out of the 62 have marked it as being malicious, that means that it's a good idea for you to keep your guard up and proceed with caution. So another tool company is Reversing Labs, which also has the file reputation service. So there's a lot of different ways that you can go and check the hash of a file to see what's up. How can you manually get the location of a hyperlink? And in what we saw in this lab, it was copy link location. But then for here, if we click on Reversing Labs, mine says copy link address. So that could be just depending. I think it depends on where you go that it'll show you that. And so this is it. reversinglabs.com is that particular link that we were just clicking on. And then if I click on file reputation service and I do copy link address here again, and then open it up, go here and register, this is the link that it would take us to. So it's a good idea to get into the habit of doing that, especially when you don't recognize an email or a sender or it looks fishy or anything like that. So that was how we can extract stuff from the body, or how to analyze the body. So now let's look at the malware sandbox, which I think is very important. The malware sandbox. So we don't need to have malware analysis skills to dissect and reverse engineer something to understand the malware better, because there are tools like sandboxes that can help us look at malicious files that can be analyzed and understand what it was programmed to do. And they're known as malware sandboxes. But then there's also something called a digital forensics sandbox that it acts the same way. Basically, you just use the sandbox, or you use a virtual machine that is designated to be the sandbox, and then you run everything that you want to run inside of that machine. And if anything were to happen, it's in a controlled environment. That's basically what a sandbox is, and it's a military term that was used to run exercises in simulations as if it was the real thing, and then you can run it inside a sandbox type of an environment to go through the motions and basically rehearse what would need to happen. And that's what a sandbox does in the digital cybersecurity environment as well. So we can upload an attachment that we obtain from a potentially malicious email and see what URL it attempts to communicate with, what additional payloads are downloaded to the endpoint, persistence mechanisms, indicators of compromise, and a bunch of other stuff. So there was one that's listed below. So this is one, this is another one, this is another one. So there's a lot of these guys. So we can just, I guess, we don't really need to go to these links because these screenshots kind of tell us. But app any run, this is something that I would just save. Like I need to actually create a document outside of these videos where I can have a cheat sheet for all of these things that I can use for future reference. But app.any.run is a malware sandbox right here that we can go ahead and create a new task and essentially upload the thing into it. We also have hybridanalysis.com, which is another one where you can just do a file or a URL and get the analysis that way. You have joesecurity.org, which is Joe Sandbox empowers analysts with a large spectrum of product features, among them live interaction, URL analysis, AI-based phishing detection, Yara and Sigma rule support, MITRE attack matrix. This is a really heavy-duty one, apparently. I would not be surprised if there is a paid version of this or something. But yeah, this is probably just three of a bunch of different versions of this that we can use for a malware sandbox type of an environment. So let's now look at Phish Tool. Tool that will help you with the automated phishing analysis is Phish Tool. So let's get into the habit of right-clicking, copy link address, and go paste it here, and it takes us exactly to phishtool.com. So I can just open it so that it's the next tab over. Stop trying to avoid phishing, choose a weapon and fight it. Get Phish Tool now for free, and then I can do this, right? Click on that, copy link address, open it, and go here, and it takes us to the Phish Tool sign up community version, right? So there's a lot of different good versions of this, a lot of cool tools that allow us to do this. And Phish Tool apparently is a commercial and community version. Then we have, yes, I saved this for last. What is Phish Tool? Be you a security researcher investigating a new phish kit, a SOC analyst responding to user-reported phishing, a threat intelligence analyst collecting phishing, or an investigator dealing with email-borne fraud. Phish Tool combines threat intelligence, OSINT, email metadata, and battle-tested auto-analysis pathways into one powerful phishing response platform, making you and your organization a formidable adversary immune to phishing campaigns that those with lesser email security capabilities fall victim to. That is a sales pitch if I've ever heard one. There's a free community edition that you can download and use. I uploaded a malicious email to Phish Tool and connected VirusTotal to my account using my community edition API key. Below are a few screenshots of the malicious email and the Phish Tool interface. And so this is kind of what it looks like. This is the title, obviously, of the email, the subject line. It's from Oscar Esquit at Grupp or whatever to, and then these are all of the CCs that have been attached to it, the return path, and then we got some 6 hops, 3 headers, etc., etc. You can see that conveniently it was grabbed for us the email sender, the email recipient, a long list of CC'd email addresses, the timestamp, and the originating IP and reverse DNS lookup right here. So we can obtain information about SMT relays and specific X header information and IP information as well by just looking further down. So this is going further down on that same screen. And then the tool notifies us that reply to no present, although it provides the alternative header information return path. So where do we have that? So I mean, I don't see it, so that's probably what they mean by like saying reply to no present. It does give us alternative information and the return path. Then to the right of the Phish tool dashboard, we can see the email body. There are two tabs across the top that we can toggle to view it in text format or the HTML source code. So this is the text format of this, and then this is the HTML source code view of this. And then the bottom panes will display information about URLs or attachments. And in this case, there were no URLs, but the attachments were the, electronic wire confirmation zip file. And from VirusTotal, 39 out of 64 different vendors said that this was malicious. Then we can grab the zip file and hashes without actually interacting with it, which is also really nice because it has the MD5 and the SHA-256 hashes. And then there's an ellipsis to the far right above. If you click that, which is this thing on the right, it'll provide additional actions, including, flag it as malicious, download it, or do anything like that. We can look at the strings output, which is all of this and all of these things. It's jargon to me, so I don't even know what the hell is going on. VirusTotal right here, 39 out of 64, malicious, we already got that. Since the API key is free, an analyst can manually navigate to VirusTotal and do a file hash search. Lastly, any submissions you upload to Phish tool, you can flag as malicious and resolve with notes, and the attachment file name and the file hashes will be marked as malicious. Then we click resolve, which is in the top section, and the next screen we can mark the email based on drop-down sections. So any of these things. So it could be a malicious attachment, it could be a spoofing thing, any of that. So you could flag it and resolve it as such. He did not perform further analysis on the domain name or IP or any of the other stuff. The reason why additional flags and classification codes weren't selected for this email. To expand on classification codes briefly, not all phishing emails can be categorized as the same. Classification code allows us to tag a case with a specific code such as whaling, which is a high value target like a CEO or a CFO, and not all phishing emails with a high value target such as Chief Financial Officer. So, not all phishing emails will target a high value target such as the CFO. So look at the strings output. What is the name of the exe file? Okay, so I guess there's something in here that's the exe. Oh, right here. Look at that. So 454326 _ PDF. And there is that. So, okay, I could have probably noticed that if I would have paid closer attention to it. As soon as I saw this, I was like, oh, I can't tell what the hell this is. And I just tuned my mind out. But literally at the very, very top, you see that it actually says it. So I should have paid closer attention to that. That is my bad. Okay, so now moving on from Phish tool to our first actual phishing case study. And it requires us to start our machine and let that load. So I'm going to let that load and we will come back to our first phishing case. All right, so here we go. Scenario. We are a level 1 SOC analyst. Several suspicious emails have been forwarded to us from other coworkers. We got to obtain details from each email from our team to implement the appropriate rules to prevent colleagues from receiving additional spam phishing emails. We're going to use the tools discussed throughout this room or our own resources to help us analyze each email header and body. Deploy the machine attached to this and yada yada yada. What brand was this email tailored to impersonate? So what's the email? Does it tell us where it is? Okay, it's probably this one email that's right here. So we're going to click on this thing and it should open it up for us. And here is the entire thing. So if I just take this whole thing, because this I think is the entire email header from what I believe, what I understand. So I'm going to highlight this I'm going to do a copy, or I'll just copy like that. And let's go to, I think it's this. So if we paste it in here first, the extracted output, look at that. So we already, right there, I didn't even need to click on anything. It already did it. So these are just the hyperlinks that were extracted here for us. Schema.org, assets, yada, 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 fonts, images, Kroger, TCO. Okay, that's that. I'm going to close this for now. Then we got, it says, what brand was this email tailored to impersonate? So can we see that from this? We can't. So let's go to, this is the reputation center. So we'll go to message header. Let's see what we can get from this. Analyze the header above. Netflix. So right there, Netflix. What is the from email address? So let's see if I can get that from here. From email address. This is the from email address. This seems to be really gnarly. I don't know if that's it, but let's see if that's actually it. Oh, okay. Wow. All right. What is the originating IP? And we want to defang the IP address. So let's get the originating IP. It's one of these two right here. Let's see if, I think it's a 3-digit IP. So it's going to be this thing. I'm going to copy that. I am going to, let's just, I guess we'll open up a new tab, go to CyberChef. And CyberChef has a very, very useful feature called defang. So we're going to just go here and we're going to defang the IP address. And then you paste that and then it does it for you. So this is the IP address originally. And then you go here and this is the defanged IP address, which basically is putting the brackets around the dots so that it doesn't become clickable. And there's that. And so from what you can gather, what do you think will be a domain of interest? Defang the domain. So let's go back to, where was it? Here? Nope, here. Nope. Where is it? Right here. Okay. A domain of interest. So let's see. All right. So we came to Talos Intelligence and I clicked on IP and domain reputation. And this is the stuff that shows up here. So we have google.com. Well, that can't be it. So block lists, maybe it's under block list. There we go. This could be a series of information for us. This is a bunch of mail data, which is Google. Let's look at the who is. There's nothing under who is. Email volume, IP addresses. Let's see what else I can find here. Okay, so that information was actually not available on any of this stuff, and I got kicked out of Talos. Talos blocked me because I was searching for this IP address. I went and pasted this IP address into Talos, and I got blocked. That was actually kind of sad and a little bit upsetting, honestly. So if I go here, this is the file reputation. So if I go to, let's go to their homepage, and let's see, web reputation, IP reputation. So let's see, IP reputation. No, where was it? There was something that I clicked on to get me to that reputation screen to be able to get that information. And when I pasted it, they said you've been blocked, basically. So I might need to log in, but we'll do that at a later point. Anyways, the answer right here for this one, I got literally by just looking at the raw email right here. And so at the very, very top, the return path is postmaster@etechnode.xyz. And then I went into CyberChef and I pasted that, and it gave me the defanged version with the thing. And then I pasted it right here, and that's the actual answer. So now we're looking for the shortened URL, and we got to defang that URL as well. And so I'm going to look at this thing to see if any of the, I mean, these look like shortened URLs. I don't know if these are the right ones, but they look like shortened URLs. So I'll just try one of these, or I'll try both of them, I guess. Let's bring it all the way over here and try this thing. Let's see if this works. That did not work. So let's try this one. Okay, neither of those worked. So now I got to do a manual hunt. Okay, so here's how we found this answer right here. It was actually very close to these two right here. But there was something wrong with this last section of these two shortened URLs. And so when I looked for t.co inside of the actual email itself, let's go back right here. When I look for this, it takes me to what is happening here, bro? My God. Let's go up one more. This is the actual text right here. So when you look at this, at the beginning of this ahref, and this is what a hyperlink HTML code starts with. It's ahref, and then it ends with the A at the very end. That is also, so let's track this down all the way. So this is the end of it. So this is the end of this whole thing right here, okay? We see that there's an image attached to it, and then there's 3D with the image. I don't know if that means three-dimensional or what, but there is several instances of 3D showing up, and it shows up before the beginning quote of the actual hyperlink. And so my guess was that if I just removed this portion of 3D equals, and then put that 1 where it was, so it would be AMP equals 1, and then just take this whole link. So https t.co, and then right after AMP equals, we just put 1, and we remove the 3D equals because this is something that was a parameter before the link started. This is a guess at this point. I'm not sure if that's actually the reason why it worked, but I did that, and I literally just did AMP equals 1, so I just removed the 3D equals from the actual link that was shown to us here, right? So 3D1, 3D equals 1, and then I just removed that section and then did AMP equals 1, and then I defanged it using CyberChef, and lo and behold, it worked. So that is the answer to the last question for phishing case 1. So now we can go into phishing case 2. For phishing case 2, I mean, the scenario is pretty much the same. Now they're saying a malicious attachment from a phishing email in the previous phishing room. So the second phishing room, because we're in the third one, the second phishing room had a bunch of different actual phishing emails that we were analyzing. And so it's saying that one of those, the attachment from that email has been uploaded to any run for us to analyze. And so this is it. And it comes, this was the update your payment information using a PDF document that was sent via Netflix. And so in this case, we are going to use that to answer these questions. So it says, what does any run classify this email as? So let's go and try to find that first. Man, this took me a long time to notice this. It's right up here. Suspicious activity is the classification activity. Yeah, there you go, man. Okay, what is the name of the PDF file? That should be right here. Payment update ID.pdf. Payment update needs to be separated by a dash. There you go. So payment update ID.pdf. And what is the SHA-256? It's at the very, very top right here. No, it's the MD5. So where's the SHA-256? All right. So actually, the easiest way to find it is we copy the MD5. We go to VirusTotal. We search for the MD5, and then we come under Details. And then under details, there's a SHA-256 code. And that should be our answer here. That is indeed our answer. What two IP addresses are classified as malicious? Defang the IP addresses, and then IP address, IP address. So let's see, do we have that here? Should be here. Let's see if we can find it under virus total. Okay, so there's a little button right here called text report, and if you open that, it brings you an entire nice report that number one, the SHA-256 hash is right here. You didn't even need to go to virus total to find it that way, but there's a lot of really neat information on here, and I have a feeling that we're going to be able to find the malicious IP addresses on here too. Yep, so here's the first one, 216.107.24. It's labeled as malicious. And is there another page? There's another page. There we go. So 216.107.83. So this is how you actually go to the second page. So page 1, 216.107.24. Page 2, 216.107.83, right here. So here we go. We're going to copy this. We're going to go to CyberChef. Paste that in here. It's going to be 1 right here. And so this will be one address. And that's 1. And then we're going to go to this thing, and we're going to go to the first address. There we go. And that's the first address. And copy that, separate by commas. There we go. What Windows process was flagged as potentially bad traffic? That one I actually saw right here, and I just know that this is not good traffic, the svc host.exe, but let's see if we can actually find it as flagged right here. Oh, right here, potentially bad traffic, svc host.exe. So there is that. Do we need to defang this too? I don't think we need to defang that because it's not a bad click. Okay, there you go. That is it. I should have just clicked on this freaking text report at the very beginning to save me some time, but apparently I like doing things the hard way. So there's that. We can now close this and we can move on to the last phishing case number 3. This is another one that is, it has a malicious attachment and it's on any run. But now that I know where to look for most information, I can do it quickly. So first and foremost, it says what kind of flag is it? So this is malicious activity. So there we go. Very good. What is the name of the Excel file? So let's try to find that real quick. Clicking on the text report right here, the same text report button brings this to us. This is the name of the Excel file. So we're going to do that. And what is the SHA-256 hash? All of this could have been found so quickly if I would have just used the report. And I would have saved myself so much time. What domains are listed as malicious? Defang the URLs and submit answers in alphabetical order. There are 3 domains. So let's go find these malicious domains. It's these guys right here. So I think this would be a B, F, and then W. Should be like this. So copy, go here and paste that. Backspace. And then take the next one, and we're gonna separate these by commas. There we go. And then take the third one and separate this by a comma. Whoops. There we go. And this should be our answer right here. No, whoops. This place. There we go. Nice. What IP addresses are listed as malicious? Submit from lowest to highest. So let's find the malicious IPs here. Got 2 IPs, I think, right? Is it 2? There's 3. There's 3 malicious IPs. Let's try to find them. All right, so all 3 of these IP addresses are listed as malicious, and they're also down here, so under the DNS requests. So we're gonna do this right here. What did I just do? That's the first one. And we need to lowest to highest, so I guess 75 would be first technically. And then 103 would be the next one, which would be between those. And this would be our answer right here. There we go. And then what vulnerability does this malicious attachment attempt to exploit? So let's see what we can do here. At the very top, we have our CVE for this vulnerability. What I can do is I can also search for this CVE to see what it shows. And it says the description is Microsoft Office 2007. Okay, so Microsoft, all these versions of Microsoft allow an attacker to run arbitrary code in the context of the current user by failing to properly handle objects in memory, aka Microsoft Office memory corruption vulnerability. That's what it is. And this is the ID number of it, and that's what we are looking for, I believe, is the ID number. Very good. And just like that, we are done. And that was it. So this was, I feel like a good analysis exercise that we were able to run. And any run is the place where we can go and check a lot of these things. And it has some really good reports. And I didn't need to sign up for anything. And I was able to run the whole thing and get the information from it. So any run is really cool. I think if I could have gotten access to PhishTool on the virtual machine, it wasn't letting me load phishtool.com to actually go and create my account. I created one on my own computer, but I would need to download or transfer the email file that we were analyzing. And I did not want to do that. So I didn't want to transfer the email file, but you're more than welcome to try to do that. Or if you can, by any chance, run PhishTool on the virtual machine that TryHackMe gives us, then you would have been able to get a lot of that information much quicker and easier. I know that PhishTool is actually probably the best tool for that, and it would have given us the IP address that we were looking for, the shortened URL that we were looking for. So a lot of the things that we were looking for would have been available if we were able to just use PhishTool, because it shows us all of that information and then some. So that was kind of the thing that I didn't have access to, and so I was doing most of the stuff manually, which kind of defies the point of, you know, using analysis tools in this particular case. So whatever, don't be mad at me, don't judge me, it's all good. We finished, and that's it for this. So I don't even need to really look at the conclusion of this. It has been quite an experience to just go through this. These are some tools that we haven't covered that we can check into. They deserve a shout out, as they say. So MX Toolbox, Fish Tank, and spamhouse.org. So that's pretty much it for this room, and we'll probably learn a lot more in the rest of this pathway, because there's still several things to do inside of the phishing pathway. If you learned anything from this room, or if you're studying for your security analyst or ethical hacker pen tester certifications, I encourage you to like, subscribe, and turn on that notification bell, because the only thing that we talk about on this channel has to do with ethical hacking, security analysis, and pen testing. And I've actually seen some comments come in where people are talking about the videos on this in this channel are actually helping them with their certification exams for Blue Team or for SOC Level 1. And so that's the kind of stuff that I love to hear, and it would be really awesome if I was able to help you in your journey as well. And apart from that, it would just be really nice to have you as a part of our community. So like, subscribe, turn on that notification bell, drop a comment if you have any questions, and I'll definitely get to them. And that's pretty much it. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker. slash protector. Love, peace, and chicken grease. If no one else loves you, Hank loves you. I will see you in the next room later. Alright, what's going on? It's your boy Hank Hackerson at Hank Hacks Hackers, and we are going into the Greenholt Phish challenge today. This is literally just a series of questions that we're going to ask or answer about a particular phishing campaign. I think this is an actual real phishing campaign. And this is the very last room of the phishing module of the SOC Level 1 pathway of TryHackMe. And this is a good one. I mean, we're going to go through all of these questions in a little bit, so we'll be able to take a deep dive into this whole thing and see what we've learned so far. If you are studying for your SOC Level 1 or Security Analyst certification or Pentest Plus or Ethical Hacker, Junior Pentester, any of those things, I invite you and I welcome you to like, subscribe, turn on that notification bell, and even drop a comment or two if you have any questions or anything like that. Would very much love to have you as a part of the community. But you also get the extra benefit that if you're studying for any of those things, these courses and these videos that we're going through are all applicable to your certification exams, and you'll learn something that will help you pass the exam. But then on top of that, you'll learn things that you'll be able to use on your day-to-day when you actually get a job as a pen tester or ethical hacker security analyst, because that's what you're here to do. You're here to learn these things to either get a job or to just become a really badass security analyst and ethical hacker. So all of those things, I think you'll be able to find some value inside of this channel. That's literally all we talk about here in this channel. So without further ado, let us jump into this room. Okay, so here is the scenario. A sales executive at Greenholt PLC received an email that he did not expect to receive from a customer. He claims that the customer never uses generic greetings such as good day and didn't expect any amount of money to be transferred to his account. The email also contains an attachment that he never requested. He forwarded the email to the SOC analyst or the Security Operations Center and for further investigation. And so we are going to investigate this email and see what is up with this freaking email. What we're going to do is we're going to open it with Thunderbird from what it says over here. And I think that's basically it. We can also probably try to use any of the other tools that we have gained through our lessons here, through the phishing tools and phishing analysis and all of that stuff to try to answer these questions. So I've already started the virtual machine. Let's see if it's up already. And it seems that it is up. So from here, I'm going to go ahead and open this challenge EML document. And we're going to open it up with, what was it? Firefox something? What is it called? Thunderbird. There we go. Thunderbird, which should be in the T's. There it is. There we got it. And we're going to open it up. Thunderbird mail. And that's going to take a couple of seconds. And so here are the questions here. So it says, what is the transfer reference number listed in the email subject? Who's the email from? What is the email address? What email address will receive a reply to this email? So we got to find the reply to email. And that is actually something that was available in the phishing emails in action. I want to see if I can use the browser to go to Phish Tool, because I've already started an account with Phish Tool. And if I can actually use Phish Tool, because I wasn't able to do it in the last video and I had to do a lot of this stuff manually, but if we can use Phish Tool to analyze the source code of this email, we'll be able to get a lot of stuff done very quickly, because Phish Tool is really, really cool like that. So they take us to CyberChef automatically, which means it implies that the internet on this thing does work. So I'm very curious as to why I wasn't able to use Phish Tool last time. So let's see if we can actually go to Phish Tool here, if it'll actually run that query. And it populated the query at the top right here, but it doesn't give me anything else. So for now, I'm just going to do manual analysis of this whole thing. So transfer reference number is going to be this thing. So we have this information is going to be our transfer reference number. I'm going to copy this and go here and paste it. That's going to be the transfer reference. Who's the email from? The email is from Mr. James Jackson. And what is his email address? It says info@mutawamarine.com. I think that's what it is. info@mutawamarine.com. What email address will receive a reply to this email? So it's very much implying that this is not going to be the full email address. And this is right here. So it says reply to is Mr. James Jackson, info.mutawamarine@mail.com. So that is going to be mutawamarine@mail.com. What is the originating IP address? This for sure we have to look at some source code to be able to find, because it's not going to be over here. So to do this, I'm going to click on more and I'm going to view source of this email, and we're going to look at the view source of this email and try to find that originating IP. So the hint tells us here that it's not in X originating IP, and then if we were to just look at X originating IP, it's literally blank anyways. So that's not going to be work. That's not going to work. There's this address at the top where it says X address or X atlas received, and that's not the answer either. So if we scroll down a little bit on this on the source code, and let me see if this will actually scroll down for us. Here we go. Okay, and right here, hopefully it doesn't skip. So it says received from this weird host, and then right there, that's the IP address that we received it from. So who is the owner of the originating IP? And so let's see, perform a whois lookup for the name of the organization. And so let's see if we can find that. So if we have the originating IP, which is this thing, I'm going to do copy, and I'm going to open up a tab, and we're going to do whois lookup. Whois IP search and whois domain lookup. So we're just going to do a paste here and see if we can find this information here. And so we have host wins, we have host wins LLC dot. So let me see, I think it's host wins LLC without the dot. There we go. What is the SPF record for the return path domain? Okay, let's try to find that. Okay, so Phish tool still is not, or the Google search for Phish tool isn't loading. So the SPF record for the return path domain, there's something that we can use from our analysis tools lab that was Google's analysis thing, and from that we can see the SPF record message header. Here we go. Okay, so to find our SPF record, and just to show you what that actually is supposed to look like, this is from our phishing prevention video that we did, and it shows the SPF center policy framework. This is what it's supposed to look like, and this is what a normal, a standard record, I guess, a basic record, there you go, basic SPF record looks like. And then if we use the Demarkian SPF surveyor tool, which is this thing right here, you just type in the domain. And so to be able to find that, I went to our source file here, and I did a basic search for the reply, the return path. So if I go here and just do a Control F and then do return path search, it shows me that right here. And so that's the domain, right? So info@mutawamarine.com. So I just searched for mutawamarine.com in the survey domain, and then it gives me the full path of the record right here. So we just take this whole thing and we copy that, and then we go to our question and we paste that here, and there it is. So what is the DMARC record for the return path domain? And so same thing, we're just going to go here to our previous task, and then we're going to go and look for the DMARC, which is this one. And to be able to find the DMARC record, we can use the health checker and check the DMARC status of this. So I can just go here, and this is the DMARC health checker. So same thing, right? The question is, what is the DMARC for the return path domain? So I just do the same thing, mutawamarine.com, and then it's going to run that for us. You have valid DMARC record, yada yada yada. So if we come under DMARC here, it gives me this information. I wonder if this is actually what I'm supposed to use. So let's see if this is the, oh, that is the answer. Very good. Okay, so there you go. So far so good. What is the name of the attachment? So let's try to find that here. That should actually be available right here. So we should be able to see that. The attachment name is this whole thing right there. So it's SWT underscore yada yada yada. So I'm going to just manually type that because I don't want to accidentally open that. There we go. And so just for your information, if you want to type that out as well, there is 1 underscore, there's 3 underscores, and then 2 underscores like that. And that's it. And so what is the SHA-256 hash of the attachment? So now what we need to do is we need to actually download this. And I just want to, oh, there we go, save button. So we're going to save this. And we're just going to save it to our desktop, like so. And then we're going to open up a terminal. This is pretty easy and fairly straightforward. And we're going to do a SHA-256 sum. Or actually, let me make sure I'm in the right place. So I need to go to the print working directory. It's home Ubuntu. So I need to go to desktop and find that. There it is. So now I'm going to do SHA-256 sum. And then I'll just do SWT and press tab, and it'll complete the entire thing for me. Press enter, and there it is. There's the SHA-256 sum right here, and it starts all the way from right there. And that's the whole thing. So we're going to do that. We're going to copy that, and very good. And we're going to do this thing, and voila. There's our SHA-256. What is the attachment file size? Don't forget to add kilobytes to your answer. And so this is also at the bottom right here. It says 400 kilobytes. So we're going to do 400 kilobytes. Oh, that's not right. Huh. Oh, I see. Okay, so they don't want us to go by that. They want us to actually go search by the file hash. So I'm going to go to virus total because I just like virus total. For some reason, there's something about virus total that I like. So it's 400.26 kilobytes. So it's not 400. So where is it? We're right here. So 400.26 kilobytes. And there's that. And what is the actual file extension of the attachment? So I'm guessing it's not cap. Yeah, so it's not cap. So let's go to this thing right here, and let's see what the actual file extension here is. So it says, let's see, family labels MSIL, Loki, Agencia. Let's go under details and see what we can find here. Oh, it's probably a RAR file, because if it's not CAB, it might, I don't think it's a TXT either. So I'm gonna say it's a RAR file, but it might be a PDF. No, it's a RAR file. Hey, there we go. We got it. That was it. That was really quick. That was actually very, very quick. So, I mean, I don't think it's complicated when you know what you're looking for. You know what I mean? When you know what resources to go to and how to find the information, it's fairly easy to do. Or yeah, fairly easy, straightforward. I don't know if easy was the right word. I had to double think or double check that with myself. But I think that it's fairly straightforward. You know, once you have the tools to use, or once you know what tools to use and where to look for certain pieces of information, the rest of it becomes very, very straightforward. And just like that, we were finished it. And this is it. I mean, so we can close this tab out. We can close this out, and close this out, and this is it. This is all that it was on this thing right here. And I was actually able to earn a badge as well, so that's nice to see, and I'm very, very excited about it. So there is our badge for Hephaestus completing the phishing module here. Super excited, and now we are done with the SOC Level 1 training. This is actually, that was the last room. So we're officially done with the SOC Level 1 training and the SOC Level 1 playlist on this channel, and I really hope that you actually learned a lot from it. I did a video for every single one of these rooms, so there's a video here for everything that's inside of this pathway, so you should have a pretty comprehensive playlist to go through and learn everything that there is to know with the SOC Level 1 pathway of TryHackMe. Alright, so if you are studying for your SOC Level 1 or Junior Analyst certification, I can't even talk right now, Junior Analyst certification, or your Pentest Plus or your Ethical Hacker, any of the certifications that have to do with cybersecurity, I encourage you, I welcome you, I challenge you to go ahead and like and subscribe and turn on that notification bell so that you get notified the next time that a video comes out. And everything that we talk about on this channel has to do with either cybersecurity, pen testing, or ethical hacking. And in that regard, you'll get a lot of stuff to help you with your examinations and your certifications, but at the same time, you'll get a lot of stuff to help you with your day-to-day stuff, your day-to-day work as a CySec analyst or SOC analyst or a pen tester, ethical hacker, all that stuff. This is directly applicable to everything that you're doing. So hopefully you learned a lot from this, and I do love the fact that our community is growing, and I would very much love to have you as a part of our community as well. Drop a comment if you have any questions, or if you want to just say hi or anything like that. I do respond to all of the comments that come in. And yeah, that's pretty much it. This is your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker / protector. This was the SOC Level 1 pathway, the very last video of the SOC Level 1 pathway. Hope you got a lot of value out of it. If no one else loves you, Hank loves you. Love, peace, and chicken grease. I will see you in the next one. Later.